Yeah, hi everyone, welcome to PrepFusion. So we are going to start vector calculus in this particular lecture, right? So from this lecture onwards, we are going to start vector calculus. But before that, I will take some 2-3 minutes of yours and I'll be telling what is the basic prerequisite. So prerequisite is integral calculus. We have already studied calculus, right? Calculus of real variable we have already studied. Limit, continuity, differentiability, application of derivative, differential calculus, then integral calculus. In that we studied about multivariable function, then single integral, multiple integral, and then polar curves. All these topics we have studied. So in that particular portion, integral calculus is very important. Double integral, triple integral, that is very, very, very important. Because without that, you will not be able to understand vector integral calculus. Okay. So that prerequisite is important. So I would say follow in the sequence. We started with the calculus. So first complete the calculus video, then only come to the vector calculus part. So you need to follow in the sequence. If you are following in the sequence, no issue. Okay. So this is the prerequisite which you can cover from this playlist. Although I hope you are watching this video in the playlist itself, right? The complete mathematics course is available on YouTube. So in the playlist only if you are watching, then it is fine. And I hope you are following the sequence. Now next would be that, sir, this is a basic video of vector algebra. Okay. Like what is the meaning of vector? What is the meaning of scalar, dot product, cross product, vector addition law? All these kind of basic things are there, no? What is the meaning of angle between two vectors? So very basic things of vectors which we have already studied in class 12th. In class 12th, we have studied vectors, no? So if someone is having no idea about vector, then he can watch this video. Even if you are having the idea about vector, then also you should watch this video. Even if you feel like that, sir, I am comfortable with the vector, then also you should watch this video in a quick manner. It will be just a quick revision of basics of vector algebra. Is that understandable to you? So basics of vector algebra, although here EMFT is written, so someone would be thinking that, sir, it is for electrical core or EC core. No. No matter whichever the branch you are from, whether you are from EC, electrical, instrumentation, civil, mechanical, no matter whichever the branch you are from, for everyone it will be helpful. Basics of vector algebra you will be able to cover from this particular video. And after covering this video, you come back to this video. In this video as well, we are going to study about basics of vector algebra only. So some discrete topics we are going to study. Let's just say first topic is equation of line in 3D, right? Then we will study about the equation of then we will study about the projection, then we will study about the equation of a plane in 3D. So these discrete topics we are discussing. Why we are discussing these topics? Because these topics will be helpful for understanding the further topics. Along with that, some questions are also asked. What is mentioned? Vector calculus is mentioned in the syllabus. Vector calculus is mentioned, but from the basics of calculus as well, they ask questions sometimes. Is that clear to you? So that's why some questions are also there. That's why we need to cover this particular portion. From the next lecture onwards, we are actually going to start the vector differential calculus. That means we will be talking about differentiation in the next lecture. But here we are going to talk about vector. Okay, and discrete topics would be there. And don't ignore this particular video. If you ignore this video, then you will not be able to understand the further lectures completely. Okay, because this will set up the basic prerequisite of the further lectures. Is that understandable to you? So this is very, very, very important. So let's get started. We need to write down the equation of a line in 3D. What is the equation of a line in 3D? You know about 3D coordinate system. All these basic things you already know. This is the 3D coordinate system. X, Y, Z. 3 axes we will have. X axis, Y axis, Z axis. So in this 3D coordinate system, what we have? We have a line. We have a 3D line where there are 2 points. This particular line is passing through 2 points, x1, y1, z1 and x2, y2, z2. Basically, if you know 2 points in x1, y1, in 2D, if you know 2 points of a line, can you write down the equation? Yes, sir. The equation is y equals to mx plus c, where the value of m is y2 minus y1 upon x2 minus x1. Right? So similarly, in 3D, what is the equation of a line? So, sir, in 3D, the equation of a line is x minus x1 upon x2 minus x1 equals to y minus y1 upon y2 minus y1 equals to z minus z1 upon z2 minus z1 equals to some constant. This is the equation of a line in 3D, which is passing through 2 points, which is x1, y1, z1 and x2, y2, z2. So a line in 3D where you know the 2 points, then you can write down the equation of this line. Is that clear to you? So this is the equation of the line. Understandable? Now this particular line will be parallel to, it will be parallel to vector A, and the vector A is x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. And isn't it pretty obvious? Yes sir, it is pretty obvious only, because what will be the vector here? If I have written AB here, so I will write down, it will be parallel to a vector f. What will be vector f? Vector f is nothing but AB vector only, no? Vector f is nothing but AB vector only. What is AB vector? AB vector is x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. So this particular line is parallel to this particular vector. The vector is, this is your vector, this is your vector, right? Is that clear to you? x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. So equation of the line is also clear. Equation of a line in 3D: x minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1, z minus z1 upon z2 minus z1 would be equals to a constant, and it will be parallel to these coordinates. Understandable? So let's see the questions. You need to write down the equation of a line which is passing through these points, which is 2, minus 1, 3. So x minus 2, it is passing through these 3 points. Minus 2, 2, minus 1, 3. And it is parallel to vector 3 I cap minus 2 j cap 6 k cap. Understandable? Passing through the points which are 2, minus 1, 3. So x minus 2 parallel to 3 I cap. Passing through minus 1 parallel to minus 2, then passing through 3 parallel to 6. This is the answer, option A. Next question. The equation of a line in 3D. This is the equation of a line in 3D. This line is perpendicular to this vector. Then find out the value of k. So this particular line is parallel to, let's just say vector A, which is 2 I cap minus 5 j cap plus k cap. Say yes or no? This particular line is parallel to 2 I cap minus 5 j cap plus k cap, right? And now this line is perpendicular to 2 I cap plus j cap minus 3 k cap. What does that mean? That means this vector and this vector is perpendicular to each other. Perpendicular to each other. They are perpendicular to each other because the line is, this is the line. Now this line is perpendicular to this particular vector. So let's just say this is the vector. Let's call this vector as vector B. Let's call this vector as vector B. And this line is parallel to this vector, which is vector A. So vector A and B are perpendicular to each other. That means A dot B would be equals to 0. Dot product of a perpendicular vectors is 0. Why is that so? Because what is A dot B? Sir, A dot B is nothing but magnitude of A multiply with magnitude of B cos theta. If the angle between them is 90 degree, if the theta is 90 degree, cos 90 is 0. That means dot product would come out to be 0 only. So for perpendicular vectors, dot product is 0. So what I need to do? I need to take their dot product and equate it to 0. What will be the dot product of 2 I cap plus j cap minus 3 k cap multiply dot product with 2 I cap minus 5 j cap plus k cap? That would be 2 into 2, 4 minus 5. I am simply doing A dot B. What I am doing? A dot B I am doing. So what will be A dot B? 2 multiply with 2, that would be 4. 1 multiply with minus 5 will be minus 5. Minus 3 multiply with k, that would be minus 3k, and that would be equated to 0. Right? So from here, the value of k is coming out to be minus 1 by 3. That's it. This is the answer. Okay, so equation of line is given. The line will be parallel to this particular vector, and then from here you can get the answer. Understandable? Very simple thing, very straightforward question as well. Okay. So 2 multiplied by 2, 4, minus 5, minus 1, minus 3k. Minus 1 minus 3k equals to 0. That answer would be minus 1 by 3. Is that clear to you? Okay, let's go to the next scenario. Scalar projection of vector A on vector B. What does that mean? Scalar projection of vector A. Scalar projection of vector A on vector B. On vector B. Projection of vector A on vector B. What is that? If you remember, sir, projection is A cos theta. The projection is nothing but A cos theta. So, sir, the projection is A cos theta. So, answer of this particular question is A cos theta. Can I write down A cos theta in this manner? A vector dot product with B cap. A vector dot b cap. This is the projection of or scalar projection of vector A on vector B. A vector dot b cap. Why is that so? Because what will be A vector dot b cap? That would be magnitude of A multiply with magnitude of b cap. That would be 1. Multiply with the angle between them, cos of angle between them. So what is the answer? A cos theta. So A vector dot b cap is the answer. A vector dot b cap. A vector dot b cap. Projection of A on B. Scalar projection of A on B. And when they talk about vector projection of A on B, what does that mean? That means, sir, first you find out the projection which is A cos theta. What does that mean? That, sir, first you find out the projection which is A cos theta. After finding the projection, you give it a direction, and the direction would be b cap. What they are saying that, sir, this is your vector A, this is your vector B. What you do is that you find out the projection of vector A. You find out the projection of vector A on vector B. So, sir, the projection would become A cos theta. So, the projection would be A cos theta. But, sir, this particular A cos theta, whatever the quantity that you are getting, you need to give it a direction as well. So, you are finding the projection of A on B. Projection of A on B, I need to give it a direction as well. So, this is my vector that I am interested in. So, this is the answer that I am interested in. So, what is the length of this vector? The length of this vector is A cos theta. The length of this vector is A cos theta. What is the direction? Direction is b cap. That means you need to find out the component of A on B which is in the direction of B. Here you just need to find out the component, no direction. Here you need to find out the component as well, and along with that direction should also be there. So, component is A cos theta only. What is the direction? B cap. Now, what is A cos theta? Sir, A cos theta is nothing but vector A dot product with b cap, and then simply take the direction. That's it. So, this is the answer of first one, and this is the answer of second one. So, what is the meaning of scalar projection? Scalar projection simply means, sir, A cos theta. What is the meaning of vector projection? Sir, A cos theta b cap. That's it. Then you can write down A cos theta very easily. What is A cos theta? A vector dot b cap is the A cos theta. Let's solve this question. Scalar projection of vector A in the direction of vector B. You need to find out the scalar projection of A on B. Scalar projection of A on B. What that would be? So that would be nothing but A cos theta. And what is the meaning of A cos theta? So that would be A vector dot b cap. That means what is your answer? A vector. A vector is 2i cap minus 3j cap plus 6k cap. Dot product with b cap. What is b cap? That is I cap plus 2j cap plus 2k cap divided by under root 2 square plus 2 square plus 1. So magnitude is 3. Can you find out the magnitude of this vector? Under root 2 square will be 4 plus 4 plus 1. Magnitude is 3. So what is the answer you are getting? So the answer I will get is 2 into 1 will be 2 minus 6 plus 12 divided by 3. So answer is 8 by 3. Okay, that's the answer. This is the answer that you are getting. Did you understand this point? Projection of A on B. It is very important. These kind of questions are very important. When we study differential calculus, it will be highly used there. Projection of a vector on the other vector. So this vector as it is, just take the unit vector of the next vector. So A vector dot b cap. Just take the unit vector. This is the unit vector. No, this is only showing the direction. What is the magnitude? Magnitude is 1. What is the direction? I cap plus 2j cap plus 2k cap divided by under root 2 square plus 2 square plus 1 square. So answer will be 3. Right? So here 2 multiplied with 1 will be 2, minus 3 multiplied with 2, minus 6, 6 multiplied with 2, 12. Okay, so answer is 8 by 3. Similarly, vector projection of vector A in the direction of B. What will be the answer? Sir, you need to find out the projection. Sir, projection will be A cos theta, but in the direction of B. In the direction of B. So what will be the answer? A vector dot b cap, then take the direction. What is A vector dot b cap? A vector dot b cap. A vector as it is. 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 Then b cap. What is b cap? 2i cap plus 2j cap plus k cap divided by 3. In the direction, what is the direction? Direction is also 2i cap plus, basically you are doing the dot product between these two guys. These two guys you are doing the dot product. The result of dot product is a scalar quantity, and then this is the direction. What is the direction? Direction is 2i cap plus 2j cap plus k cap divided by 3. So now you do the dot product. What is the answer you will be getting? 4 into 2, 8 plus 4 plus 4. So what is the answer? 16 by 3. 16 by 3 is the answer. 16 by 3 is the answer. Okay. So when you do the dot product, what is the answer? 16 by 3. And here 2i cap plus 2j cap plus k cap divided by 3. Now 3 and 3 could be multiplied. So answer is coming out to be 16 by 9, 2i cap plus 2j cap plus k cap. That's the answer that you are getting. I hope it is completely understandable. Vector projection of a vector in the other direction, in the direction of b. That means first you need to take the projection which is a cos theta, then you take the direction which is b cap. So a vector dot b cap with the direction of b cap. So what is a vector? This is the a vector. What is b cap? This is b cap. Simply do them. So what is this? This is the scalar component that you have got. This is the answer that you have got here. Although here answer is different because vectors are different. Here vector is different, no? This vector was different and this vector is different. So this is the scalar component that you have got. Along with that you need to add the direction as well. Whenever I say direction of a vector, what is the meaning of direction of a vector? Whenever I say direction of a vector means a unit vector. Direction of a vector. Direction of a vector. What does that mean? That means you need to find out the unit vector. That's it. If a random vector A is given, let's just say a random vector C is given, which is 2i cap minus j cap plus 3k cap. What is the direction of this vector? What is the direction of C? Direction of this vector. So simply what you need to do? Simply you need to find out the unit vector. What is the meaning of unit vector? So 2i cap minus j cap plus 3k cap divided by under root 2 square plus 1 square under root 2 square, that would be 4 plus 1 square will be 1 plus 9. So answer will be under root 14. Under root 14. This is the direction of the vector. Okay. And surely you know the magnitude. Magnitude is under root 14 only, right? What is the magnitude? Magnitude is, if you take the magnitude 4 plus 1, 5 plus 9, that would be under root 14. So magnitude is under root 14 and this is the direction. So vector C could be written as magnitude is under root 14 and the direction is 2i cap minus j cap plus 3k cap divided by under root 14. So this is how your C vector could be written, where this shows the magnitude, very basics of a vector we are talking about, and this shows the direction. Understandable? Let's go to the next topic. Now here we are studying discrete topics, right? Like first we studied about equation of line, then suddenly sir something else came up, projection, right? Now suddenly sir something else is coming up. So these are the discrete topics. Why they are discrete? Because they will be helpful in the further lectures. Along with that, they will be helpful in solving the gate PYQs as well. Is that clear to you? So what is our next topic? The next topic is equation of a plane in 3D. So let's just say there is a plane given in 3D. This is your XYZ coordinate system. Okay. This is the plane that is given. This is the plane that is given. This is the plane in 3D. Plane in 3D means, let us say, although it is a cuboid, but just assume this as this is having 0 width. Just assume that this width is 0. So this is the plane. This is a plane, right? This is one plane in 3D, right? So you need to write down the equation of this plane in 3D. So what is the equation of this plane? The equation of this plane is ax plus by plus cz equals to d, or you can write down ax plus by plus cz minus d equals to 0. This is the equation of a plane in 3D. Okay. Ax plus by plus cz minus d equals to 0. There could be other way as well, no? What you do is that you take a common. If I take a common, what I will be getting? Plus c by a minus d by a equals to 0. Now I can give it a different variable. B by a I can call as capital B. C by a I can call as capital C. And this I can call as capital D. So you just remember this answer. That's it. Which answer you will remember? This answer you remember. That's it. From this answer you can make this answer very easily. So equation of a plane in 3D is ax plus by plus cz equals to d. Could be written in this way as well. Okay. Now what is given? Now you are given a plane. In 3D you are given a plane. This is the plane that is given. When I am making these lines, that means this is a plane. This is the plane. This is the plane that is given. Now there is a point P. There is a point P, which is x naught, comma y naught, comma z naught. Okay, this is the point P, x naught, comma y naught, comma z naught. And what is the equation of this plane? So the equation of this plane is ax plus by plus cz equals to d. This is the equation of this plane, and this point is given. You need to find out the distance of this plane from point P. That means which distance you are supposed to find out? You are supposed to find out this particular distance. You are supposed to find out this particular distance. This distance is alpha. You are supposed to find out this particular distance. So you are supposed to find out alpha. What will be alpha? So what you need to do? You need to write down ax plus by plus cz minus d. So this we already know, ax plus by plus cz minus d. Now in place of x, y, z, you put these coordinates x naught, y naught, z naught, x naught, y naught, z naught. Then whatever the value that you get, take its mode. It is not difficult, okay? The formula is not difficult. Questions have also been asked from this particular topic. 2-3 questions in examination. Okay, not only once, 2 or 3 times. So what you do? The point is given. You put the coordinates of these points in this equation, which is ax plus by plus cz minus d. Here you put the coordinates, and then whatever the answer that you get, you take the magnitude of that divided by under root a square plus b square plus c square. The only error you might do is that you will write down under root plus d square as well. So don't write down d square. Okay, this is the error a lot of guys can do, that here they will write down under root d square as well, but d square will not come. So what is the formula? This is the formula of the distance. That the equation of the plane is given ax plus by plus cz minus d equals to 0. So you take the, from here you take only the left hand side, ax plus by plus cz minus d equals to 0. So you only take the left hand side. In this left hand side, in place of x, y, z, you put these coordinates x naught, y naught, z naught. Then whatever the answer that you will be getting a numerical value. Take its mode divided by under root a square plus b square plus c square. So simply take the under root and square of these coefficient of x, coefficient of y, coefficient of z. Let's solve a problem. It will be completely clear to you. You need to find out the perpendicular distance of point P from the plane 2x plus y minus z equals to 1. So what you will do? First of all, you will make 2x plus y minus z minus 1 equals to 0. So now what you need to do is that in place of x, you are supposed to put this point. In place of y, you are supposed to put this point. And in place of z, you are supposed to put this point. Minus 1. Whatever the answer that you will be getting, you will be taking its mode divided by under root coefficient of x, which is 2 square, coefficient of y, which is 1 square, coefficient of z, which is minus 1 square. That's the answer. So 4 minus 1 minus 3 minus 1. So answer you are getting is minus 1 here. You need to take its mode divided by under root 6. So what is the answer? 1 by under root 6. So distance of a point P from the plane, which is 2x plus y minus z equals to 1. What is the distance? Distance is 1 by under root 6. How will you find out the distance? Very simple, very easily you will be able to remember that, sir, in the equation 2x plus y minus z minus 1 equals to 0, you put the point 2 comma minus 1 comma 3, then under root coefficient of x whole square plus coefficient of y whole square plus coefficient of z whole square. Someone would be saying that, sir, where are the proofs of all these things? Sir, where is the proof of this equation? Look, we are not studying vector algebra completely, right? You are not in the class 11th, 12th. I can give you the proof of everything, but it is not required, no. When we study differential calculus, when we study vector differential calculus, I will give you proof of every single statement. Whatever the statement that I am writing down, no. Proof of every single statement I will give. But here it is not required. This question has been asked in GATE examination. How will you solve this question if it is coming in your examination hall? Proof is not required here, no. If you know the formula, job is done. If you don't know the formula, that means it is gone. That's it. There is nothing in between. So there is a plane OQR. You can read the question. So there is a plane which is OQR. You need to find out the distance of point P from OQR. That's it. From OQR, using 3 points, we are making a plane which is OQR. you need to find out, let's make it look somewhat like this. This is your plane OQR. It is not an easy question although. OQR. What will be the coordinate of O? 0, 0, 0. What is the coordinate of Q? 1, 3, 4. And what is the coordinate of R? 2, 1, minus 2. You need to find out from point P what is the distance. What they are saying in the XYZ coordinate system, O is the origin, then perpendicular distance of the point P from the plane OQR. So this particular distance you are supposed to find out. This particular distance you are supposed to find out. So this is the distance which is alpha we are supposed to find out. What is the coordinate of point P? Coordinate of point P is 3, minus 2, 1. Minus 1 actually. 1, 3, 4, 2, 1, minus 2. 1, 3, 4, 2, 1, minus 2. And coordinates are 3, minus 2, minus 1. 3, minus 2, minus 1. 3, minus 2, minus 1. So here first task is you don't even know the equation of this plane. What is the equation of this plane? What is the equation? So sir, equation of the plane I know, ax plus by plus cz minus d equals to 0. This is the equation. Sir, I am having 3 points. On this plane there are 3 points, no? Like basically this equation will be satisfied by these 3 points, no? Are you able to understand this point? This equation will satisfy these points because these points are lying on this particular plane. On this plane, on OQR plane, point O is lying, point Q is also lying, and point R is also lying. So on this OQR plane, you can put these points 0, 0, 1, 3, 4, 2, 1, minus 2. These points you can put. But sir, I will have 3 equations only, but here there are 4 variables. So do you really think there are 4 variables? No, there are only 3 variables only. B by A, C by A, minus D by A. I told you there is other equation as well. X plus by plus cz minus d equals to 0. So x plus by plus cz minus d equals to 0. This is the equation of the plane, and it will be satisfied by 3 points which are 0, 0, 0, 1, 3, 4, 2, 1, minus 2. So here you put 0, 0, 0. In this equation if I put this point, so 0 plus 0 plus 0 and d is a constant, is coming out to be 0 only. So from here the value of d is coming out to be 0. Value of d is coming out to be 0. So now since the value of d is coming out to be 0, so the equation has become x plus by plus cz equals to 0. This is your new equation. X plus by plus cz equals to 0. This is your new equation. Now in this equation what you need to do? You need to put the point 1, 3, 4. What point you need to put? 1, 3, 4. 1, 3, 4. And what else you need to put? You need to put the point 2, 1, minus 2. 2, 1, minus 2. So 2, 1, minus 2. Right? 2, 1, minus 2. So these 2 equations we are having, this equation and this equation. Solve these equations and get the value of b and c. So what we can do is that 6 equals to 0, right? I just multiply this equation with 3. Now what I will do? I will subtract these 2 equations. So minus 5 plus 10c equals to 0. So value of c you are getting is 1 by 2. Is that correct? If the value of c is 1 by 2, then value of b is 1. Minus 1. Value of b is minus 1. Yes, value of c is coming out to be 1 by 2 and value of b is coming out to be minus 1. This is the answer that we are getting, c and b values. So what is the equation of the plane? Equation of the plane is coming out to be x minus y plus z by 2 equals to 0, or you can say 2x minus 2y plus z equals to 0. This is the equation of the plane. Let's put up the points and let's check if this equation is correct or not. 1, 3, 4. 1, 3, 4. 1, 3, 4. Yes, satisfying. And the next one is 2, 1, minus 2. 2, 1 comma minus 2. Yes, so this is the equation of the plane. This is the equation of the plane. So did you understand the equation of the plane? Did you understand how did we find out the equation of the plane? Yes sir. So this was simply the equation of the plane. It was passing through 0 comma 0 comma 0. So I just put 0 comma 0 comma 0 here. I go to this particular result. From here I just have two variables and I just need to put these two values, these two coordinates in this particular equation. So 1 plus 3b plus 4c equals to 0. 2 plus minus b plus 2 plus b minus 2c equals to 0. I just need to solve these two equations. When I solve these two equations, I go to know, sorry, not these two equations. I need to solve these two equations, this equation and this equation. Then what did I understand? The answer is coming out to be c equals to 1 by 2 and b equals to minus 1. Just I put it here. This is the equation of the plane. So now I am having the equation of the plane. Equation of the plane I am having. This is the equation of the plane that I am having. Along with that, I am having the coordinate as well. Which coordinate I am interested in? I am interested in this coordinate, which is 3 comma minus 2 comma minus 1. 3 comma minus 2 comma minus 1. You are supposed to find out the distance alpha, right? So what will be alpha? Sir, alpha will be nothing but 2. Then you need to put this coordinate, 2 into 3 minus 2. Then you need to put this coordinate plus z, you need to put this coordinate minus d, that is 0 only. So don't care about it. Then whatever the answer you get, you take its mode, then divided by under root coordinate of x plus coordinate of y plus coordinate of z. So 6 plus 4 minus 1. So what is the answer? 9 divided by 3. Right, so answer is coming out to be 3. Is that the correct answer? Yes, answer is 3 only. So that's the correct answer that we are getting. So when you put, the answer is 3. Not a very easy question. This kind of question would be considered from moderate to tough only, because it will not click in the examination, no, that you need to find out the equation of the plane. Equation of the plane is not given. So although this equation might click, ax plus by plus cz minus d, but calculation will be complex from here, because one variable, all the variables like b would be coming in terms of a, c would be coming in terms of a, d would also be coming in terms of a. Then what you would do is that you would take a common and a will be thrown to 0, right? But in this manner you can write down the equation, you can find out the equation of the plane. Once you are having the equation of the plane, which is 2x minus 2y plus z equals to 0, then job is done. Simply put the coordinates here, then take its mode, divided by under root x coordinate square plus y coordinate square plus z coordinate square. That's it. Okay, so answer is 3. So it is a gate PYQ only which we have solved. So 3 topics we have seen, starting with the equation of a line in 3D, then projection, and then equation of a plane and the distance of a point P from the plane. Next topic is this is not a topic, this is a question. Directly it is a question which is also asked in gate examination. Try solving it on your own. The magnitude of a position vector of a particle remains constant through its motion. Position vector. What do you mean by position vector? Do you know what is the meaning of position vector? In 3D coordinate system, the position vector is, let's just say I need to define the position of this particular point. What is the position of point P? You will say, sir, it is you will say, sir, it is x comma y comma z. Now x could be 1, y could be 1, z could be 1, x could be 1, y could be 2, z could be 3. So a position of point P in Cartesian coordinate system is defined as x comma y comma z. In cylindrical coordinate system, it is defined as rho comma phi comma z. Do you remember it? And in spherical coordinate system, it is defined as r comma theta comma phi. Right? So this is how it is defined. So now we can define a vector called position vector, which is OP vector. OP vector means we need to take its position from the origin and we need to define a vector which is known as OP vector, and this is known as your position vector r. So position vector r is nothing but x I cap plus y j cap plus z k cap. This is your position vector r. Is that understandable to you? So what they are saying, magnitude of the position vector r is constant throughout the motion. That means magnitude of the position vector r is constant throughout the motion. This is what they are saying. Now do you remember one thing? What is a vector dot a vector? So that is magnitude of vector a whole square. Understandable? So can I do the square on both of the side? Can I do the square on both of the side? Yes sir, if I do the square on both of the side, it is again a constant only. Square of a constant is constant only, no? Right? So let's call this as C1. So C1 square I am calling as capital C. So what you are getting? Magnitude of position vector whole square is constant. Can I write it down as r vector dot r vector equals to constant? Yes. Now which of the following statement is true about the velocity vector? What do you mean by velocity vector? Position vector is r vector. Position vector is r vector. R vector. Velocity vector would be velocity vector would be what? That would be dr by dt. And what will be acceleration vector? Acceleration vector that would be one more time differentiation. I hope you know the relation between position, velocity and acceleration. R vector dr by dt, d square r by dt square. Understandable? So if I need to find out velocity vector, what I need to do? Differentiate on both of the side. Differentiate on both of the side. That means differentiate by t on both of the side. Differentiate by t on both of the side. What will be the value of constant differentiated with respect to t? 0. What is the value of this? First as it is, differentiation of second plus second as it is, differentiation of first. What I am doing? I am doing d by dt of a vector dot b vector. So that could be written as a vector. Do I have the page? No. So let's do one thing. In one page only there has been a lot of information. So let's do it on the next page. What I am doing here is that d by dt of a vector dot b vector. It could be written as first one as it is, differentiation of second plus second as it is, differentiation of first, and there is dot product in between. Dot product. This quantity will be a vector only, no? Let's just say b vector is nothing but 2t I cap plus t square j cap plus 3k cap. Okay. Now if you differentiate it, what you will be getting? You will be getting 2 I cap plus 2t j cap plus 0k cap. Right? You need to differentiate with respect to t. So here this will become 2, this will become 2t j cap, this will become 0, because differentiation of 3 will be 0. So this is also a vector quantity only. So this is also a vector quantity. This is also a vector quantity. So vector quantity dot product with the vector quantity, and this will also be a vector quantity. So vector dot product with vector. So this is the scenario that you are getting. Understandable? So from the previous slide, here what we have done. Here we saw that this is coming out to be constant. R vector dot R vector is coming out to be constant. So similar thing I will do here. First one as it is, differentiation of second plus second one as it is, differentiation of first. Both are the same, so I can write down 2 r vector dot dr by dt equals to 0. So from here what you can get, r vector dot dr dt equals to 0. This is what you are getting. So what you can see here, that p vector dot q vector is coming out to be 0. So from here I can see that p vector is perpendicular to q vector. So similarly, r vector will be perpendicular to dr by dt vector. There you go. So which statement would be correct? The velocity vector is parallel to the position vector? No. Velocity vector is perpendicular to the position vector? Yes. Anti-parallel? No. Has the same magnitude? No. Okay. So this is the scenario that we are getting, that they are perpendicular to each other. R vector is perpendicular to the position vector. What this is known as? This is known as, this is your position vector and this is your velocity vector. So position vector is perpendicular to the velocity vector. Understandable? If the magnitude remains the constant. If the magnitude remains the constant. Okay. We can understand this by the graph as well. How we can understand by the graph? If ये क्या हो गया यार? Just 1 second, guys. Just 1 second. Yeah, sorry for the interruption, guys. Actually, the screen started lagging in between, but now it is fine. Yeah. So what I was saying? Yeah, I was saying that there is another way of solving this particular problem. If you are good enough with physics, if you know the physics. So I'm asking you a very simple physics question. That let's just say this is the sphere I'm having. If I am moving on this sphere, let's just say I am at this point, I am moving on this sphere, I am at this particular point. If I ask you what is the direction of my velocity vector, what will be your answer? The direction of velocity vector will be tangential to the surface, right? Tangential to the surface. I am discussing so much because it has been asked in GATE examination. Although it is a physics question only. The direction of velocity vector will be tangential to the surface, right? Now what is given? It is given that the magnitude of position vector is constant. Magnitude of position vector being constant. What is the magnitude of position vector? What is position vector? That is, sir, x I cap plus y j cap plus z k cap. What is the magnitude of position vector, sir? That would be nothing but under root x square plus y square plus z square. And sir, that is given as constant. Can I write down this as, that is given as constant, that which is C1. So can I write down this as x square plus y square plus z square equals to C1 square, that is equals to constant. What is this? This is the equation of a sphere. That means all the position vectors combined, all the position vector combined will be making a sphere actually. All the position vectors combined will be making a sphere. What does that mean? That means, sir, you will be actually, if you are saying that no matter wherever I walk, if you are saying no matter wherever I move, always my position vector is constant. If you are saying no matter wherever I move, always my position vector is constant. That means you are actually moving on a sphere. You are actually moving on a sphere, because if you move on the sphere, then only your position vector would be constant. If you move on a sphere. If you move on a sphere, on this particular sphere we are moving. Do you understand this point? This is the surface. This is the surface. So on this particular sphere you are moving. So when you move on this sphere, no matter where, if you are at this point or you are at this point or you are at this point, you take the position vector from the origin. Position vector from the origin. You take the position vector from the origin. 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 No matter at whichever the point you are. No matter at whichever the point you are. At every point, at every single point, your position vector, magnitude of position vector would be constant. Magnitude, I am talking about the magnitude of position vector would be constant. That means you are actually moving on the sphere. And now let's just say if I am at this point, what this is my position vector, right? This is my position vector. This is my position vector. Which position vector I am talking about? This is my position vector, r vector. This is my position vector. Now at this particular point, what will be the direction of my velocity vector? What will be the direction of my velocity vector? So direction of velocity vector will be tangential to the surface. Tangential to the surface. Tangential to the surface. This will be the direction of the velocity vector. This is the direction of the velocity vector. So velocity vector is tangential to the surface, and this is the position vector. Aren't they making an angle of 90 degrees? So from here it is clear that r vector is perpendicular to dr by dt. There you go. So if you know the physics, then with the diagram only you will be able to understand. You don't need to apply mathematics. Okay, your position vector, magnitude of position vector is constant. That means you are moving on a sphere. If I am moving on a sphere, then my sir, velocity will be tangential to the surface. Velocity is tangential. This is my position vector. Are they making an angle of 90 degree? Absolutely. They are making an angle of 90 degree. That means they are perpendicular to each other. That's it. Is that clear to you? Understandable? Let's go to the next question. Next topic or next question, area of a triangle. How the area of a triangle is given. in terms of vector. So these are the coordinates, I should not say coordinate, these are the points A, B, C. So the area of a triangle is given as 1 by 2 multiply with, you take A, from point A, how many vectors you can frame? Sir, I can frame AB vector and AC vector. So 1 by 2 AB vector cross product with AC vector, and then take its magnitude. So 1 by 2 magnitude of AB cross AC, or sir, I will stand at B. From B, sir, what two vectors I can make? BC vector and BA vector. So magnitude of 1 by 2 BC vector cross BA vector. Sir, from C, what all vectors I can make? 1 by 2. Sir, from C I can make CA vector cross CB vector. So this is how the area of a triangle could be defined. And how the area of a parallelogram could be defined? Area of a parallelogram. So you stand at A. Okay, you are standing at A. So from A, sir, I can make AB vector and AD vector. So here 1 by 2 will not come. AB vector multiply with AD vector. Take its magnitude. You stand at B. So from B, sir, I can make BA vector and BC vector. So magnitude of BA vector multiply with BC vector. You are talking about the magnitude. Someone would say that, sir, what if I write down BC first and BA later on? You are talking about the magnitude, no? So negative sign will not make any impact. We are only talking about the magnitude. Or 1 by 2, sorry, 1 by 2 will not come here because we are talking about the parallelogram. In triangle 1 by 2 will come, in parallelogram 1 by 2 will not come. From C I can make CD vector and CB vector, and from D I can make DA vector and DC vector, right? So this is the area of a parallelogram. Understandable? So from this as well, one question has been asked in GATE examination. This is a GATE examination question only. What is given? Read the question carefully and then give the answer. A, B, C are the position vector of point A, B, C respectively with respect to origin O. The area of a triangle framed by the points A, B, C is. What they are saying? You need to frame a triangle with the points A, B, C. There are 3 points A, B, C. There are 3 points A, B, C. B, C. Now using these 3 points, you are framing a triangle ABC. You need to find out its area. This is the question. Now what is given? A vector is the position vector of point A. A vector is the position vector of point A. Position vector of point A means, let's do one thing. Let's make a triangle in a bit different way. Okay, I am making a triangle in a bit different way. This is how I am making a triangle. This is your A point, this is your B point, and this is your C point. Okay, so this is your A vector. What is your B vector? This is your B vector. And what is your C vector? This is your C vector. Is that understandable to you? By the language it is understandable. A, B, C are the position vector of point A, B, C. So this is your C vector. You need to find out the area of the triangle. What is your triangle? Triangle here I am making outside. This is your triangle. This point is A, this point is B, this point is C. Now you notice one thing, that if you take out this much of triangle outside, can you notice one thing? Sir, I notice one thing here is that if I take out this triangle outside, this triangle I am taking outside, this is origin O, this is your A vector, right, and this is your B vector. This point is A, this point is B. If I need to define AB vector, what will be your AB vector? Can you let me know? So I know that A vector plus AB vector will be equals to B vector. That means, sir, AB vector would be given by B vector minus A vector. So, sir, AB vector would be given by B vector minus A vector. Do you agree to this point? This AB vector is given by B vector minus A vector. Did you understand or not? Just take out this triangle, no? Just take out this triangle. What law I have applied here? Vector addition, right? A vector plus AB vector is given, will be equals to B vector. So, AB vector is given by B vector minus C vector. So, similarly, AC vector will be given by what? AC vector will be given by C vector minus A vector. This will be given by C vector minus A vector. C vector minus A vector. So, I know two vectors, AB vector and AC vector. I know both of the vectors, AB vector and AC vector. What I am supposed to find out? I am supposed to find out the area. That would be 1 by 2. AB vector is B vector minus A vector. Cross product with AC vector, which is C vector minus A vector. That's it. This is the answer. Sir, no option is matching. Sir, this option is somehow matching. Yes, this will match, no, because you can take out the negative sign. Why I can take out the negative sign? Sir, I can take out the negative sign because, sir, I am just interested in the magnitude. I am only interested in the magnitude, so I can take out the negative sign. So, what is the answer? 1 by 2. A vector minus B vector cross with A vector minus C vector. This is the answer. Option B is correct. Is that understandable to you? Sir, area is 1 by 2. AB vector, what will be the area? Area will be 1 by 2 AB vector cross AC vector. AB vector cross AC vector. Right? So, area will be 1 by 2. AB vector is B vector minus A vector. How it is B vector minus A vector? Sir, if I look at this particular triangle, I can apply the vector addition law. I got to know that it is B vector minus A vector and this is C vector minus A vector. So, 1 by 2 B vector minus A vector cross product with C vector minus A vector. What I can do? I can take out the negative sign because I am interested only in the magnitude. So, I took out the negative sign. Option B is matching. Let's go to the next question. This is also gate PIQ only. All are gate question only. Okay. This parallelogram is given. You need to find out the area. What will be the area of this parallelogram? Sir, area of this parallelogram will be nothing but OP vector cross product with OR vector. What is OP vector? Sir, OP vector is nothing but AI cap plus BJ cap. Again, magnitude. AI cap plus BJ cap cross product with CI cap plus DJ cap. So, you can do the multiplication. Answer will come out to be AD minus BC. Okay. Again, magnitude. So, this is the answer. AD minus BC will be the answer. That's it. OP vector is given, OR vector is given. Right? Or what they can do is that they can define this as 0, 0. They can define this point as A, B and this point as C, D. And then they can ask you what is the area of this parallelogram. So, what you will do? You will define OP vector, you will define OR vector, magnitude of OP cross OR. That's it. So, if OP vector I already know, OR vector I already know, answer would be magnitude of AD minus BC. Understandable? Let's go to the next question. Find the vector perpendicular to both of the vectors which are BA vector and BC vector. So, there are two vectors. One vector is BA vector and one vector is BC vector. BA vector and BC vector. Two vectors are there, BA vector and BC vector. You need to find out the vector which is perpendicular to both of the vectors. What does that mean? That simply means that, sir, there is a plane. There is a plane. What do I say? There is a plane. As I said, this is my plane. In this plane, two vectors are lying. This is one vector and this is another vector. In this particular plane, two vectors are lying. These two vectors are there. One is BA vector, one is BC vector. You need to find out the vector which is perpendicular to both of them. That means you are supposed to find out this particular vector. Say yes or no. That means on this particular plane, two vectors are lying. These two vectors are lying. This vector, this point is B. So, BA vector is there, BC vector is there. You are supposed to find out the vector which is perpendicular to both of them. So, what will be that vector? That vector will be this vector. Say yes or no. Okay. So, what I will do, I will find out the unit vector. I will find out the unit vector. And based on that, I can match the options. Okay. I will find out the unit vector. Based on that, I can match the options. Okay. So, this is the question that they are asking. So can you find out this an vector? What will be BA cross BC? Sir, BA cross BC will give me magnitude of BA multiply with magnitude of BC multiply with sine of angle between them. Direction will be perpendicular to both of them, right? What is the direction of cross product? What is the direction of A cross B? Direction of A cross B will be perpendicular to the plane containing vector A and vector B. So what will be the direction of BA cross BC? Direction of BA cross BC will be perpendicular to the plane containing BA vector and BC vector, and this is what we are supposed to find out. So our target is to find out AN vector. That's it. Job done. Is that understandable to you? Right? So I can find out the vector which is perpendicular to both of them. I am finding out a vector which is perpendicular to BA and BC. So vector perpendicular to both BA vector and BC vector. BA vector and BC vector will be nothing but BA cross BC. This vector will be perpendicular, but it is not a unit vector. It is not a unit vector. It is not a unit vector. You can find out the unit vector and then you can match the options. So our target is to find out BA cross BC now. So can I find out BA cross BC? Absolutely. I can surely find out BA cross BC. 0, -4, -3, 3, 0, 4. So BA cross BC would be I cap -16 minus j cap 9 plus k cap 12. Right? Can you do the multiplication? I hope you know this result. The result we are getting is 16 minus 16 I cap minus 16 I cap minus 9 j cap plus 12 k cap. So this particular vector is perpendicular. So answer minus 16 I cap minus 9 j cap plus 12 k cap. This is one of the option. Now let me know one more thing. I am asking you one question, that if an vector is perpendicular, if this an cap is perpendicular, although it is not a unit vector, it is not a unit vector, right? It is not a unit vector. This vector that we have found out, it is not a unit vector. It is a random vector which is surely perpendicular to BA and BC. Let me know BA cross BC will be perpendicular to BA and BC or not. Yes sir, surely it will be perpendicular. So that vector we have found out, and one of the option is also matching. Along with that sir, this vector will also be perpendicular only, no? The vector in the opposite direction, the vector in the opposite direction will also be perpendicular only. If let's just call this vector as some vector P. If vector P is perpendicular to AB vector and not AB, it is BA. A vector P is perpendicular to BA vector and P is perpendicular to BC vector as well, then minus P will also be perpendicular to BA vector and minus P will also be perpendicular to BC vector as well. Say yes or no. So sir, if this is the answer, minus 16 I cap minus 9 j cap plus 12 k cap, then surely sir 16 I cap plus 9 j cap minus 12 k cap will also be the answer. And if P vector is perpendicular, then similarly, just take the same scenario and multiply this with alpha. Then alpha into P vector and alpha into P vector will also be perpendicular to BA vector and BC vector. What do I mean to say is that this was the plane. In this plane there were two vectors. This vector came out to be perpendicular. I am calling this as P vector. Then P by 4 will also be perpendicular only, no? P by 4 will also be perpendicular. P by 4 will also be perpendicular. P by 8 will also be perpendicular. P by 8 will also be perpendicular. P by 8 will also be perpendicular. Minus P will also be perpendicular. Minus P will also be perpendicular. Minus P by 4 will also be perpendicular. Minus P by 4 will also be perpendicular. Minus P by 4 will also be perpendicular. So similarly, just divide this by 4. What answer you will be getting? 16 by 4 will be 4. 9 by 4 will be 2.25. Divided by 4, that would be minus 8. This answer is also correct. What about this guy? 0 vector is always perpendicular to all the vectors. 0 vector is perpendicular to all vectors. All vectors. Let's just say there is a random vector P which is xi cap plus yj cap plus zk cap. What is 0 vector? 0 vector is 0 I cap plus 0 j cap plus 0 k cap. 0 vector dot product with P vector. What is the answer you are getting? 0 only. So if a dot product of two vectors is 0, what does that mean? That means O vector is perpendicular to P vector. O vector or 0 vector. So 0 vector is always perpendicular to all the vectors. So in the option, if 0 vector is mentioned, blindly you click on this option. How you could have solved this question? You could have solved this question with the options as well. What you could have done, that you multiply these two vectors and see if the answer is coming out to be 0 or not. What I mean to say is that method 2 would have been, you multiply BA vector with 16 I cap. BA vector multiply means I mean to say you do the dot product. So BA vector dot product with 16 I cap plus 9 j cap minus 12 k cap. This will come out to be 0. Along with that, you take BC vector. Along with that, you take BC vector and do the dot product with 16 I cap plus 9 j cap minus 12 k cap. You will also see that this is also coming out to be 0 only. This will also coming out to be 0. Okay. What does that mean? That means they are perpendicular to each other. They are perpendicular to each other. They are perpendicular to each other. So they will be in that manner. Or you can check option B as well. You can check option C as well, and you can check option D as well. So option checking can also work. If you need the concept, that means if we need to find out the vector which is perpendicular to two vectors, right? What is the conclusion we can make? If we need to find out a vector A which is perpendicular to B and vector A which is perpendicular to C as well, then direction of A will be same as direction of B cross C. Is that clear to you or not? Direction of A will be same as direction of B cross C. Is this conclusion clear or not? Similar thing we have seen here. Two vectors are there. I need to find out a vector which is perpendicular to both of them. That means it should be perpendicular to the plane which is containing these two vectors. That means I will simply find out the cross product. Whatever the direction of cross product that I am getting, that will be my answer. So direction magnitude could be anything. It could be magnitude could be P, it could be P by 4, it could be P by 8, it could be minus P by 4, minus P. Magnitude could be anything. I just need to know the direction. Once I know the direction, then magnitude I can divide by 4, I can multiply with 4, I can multiply with minus 1, I can multiply with 0 as well. Because 0 vector will always be perpendicular to all the vectors. Is that clear or not? Absolutely clear. Let's go to the next question. This is also GATE PIQ only. In recent year only it has been asked in electrical, GATE 2023 electrical. So in this figure, vector U and V are related as AU equals to V by transformation matrix. Then what is the correct choice of vector A? What is vector U? Vector U. What is vector U? Vector U is 4 I cap plus 3 j cap, right? This is your vector U. This is your vector U. This is your 4 I cap plus 3 j cap. And what is your vector V? Vector V is nothing but 5 I cap only. 5 I cap plus 0 j cap. So vector V is nothing but 5 I cap plus 0 j cap. How they can be written in matrix format, that also you know. Now you need to find out a matrix A, which will be A, B, C, D. Matrix A multiply with vector u, which is 4 comma 3, will give you the result of 5 comma 0. That's it. So now check the options. From here what you are getting, 4a plus 3b equals to 5, and 3c plus 4c plus 4a plus 3b equals to 5, and 4c plus 3d equals to 0. So what you understood, that sir, in the second row, first element multiply with 4 and second element multiply with 3 should give me the result after the addition equals to 0. These two options are gone, because here you see c multiply with 4, that will be 12 by 5, and this multiply with 3, that will also be 12 by 5. So 12 by 5 plus 12 by 5 will become 24 by 5. Same goes with this one as well. So both of the options are gone, right? Now we are left with these two options, option A and D. Both of the options are satisfying this equation. You multiply this 4 minus 12 by 5, multiply this with 3, 12 by 5. So minus 12 by 5 plus 12 by 5, 0. Here also 0 only. Check this condition. First element multiply with 4, second element multiply with 3 should give you 5. First element multiply with 4, this multiply with 3. So 16 plus 9 divided by 5. 25 by 5 should give you 5. So this option is correct. What about this one? Multiply with 4, that will be 16 by 5. Multiply with 3 will be minus 9 by 5. So this is giving you 7 by 5. That means this option is also wrong. So by the options, very simple question, directly you need to check. Just assume any matrix which is A, B, C, D. From there you get the equation 4a plus 3b equals to 5, 4a plus 3b equals to 5, 4c plus 3d equals to 0, 4c plus 3d equals to 0. Only one option is satisfying, option A, correct. Let's go to the next one. This also has been asked in recent year only in GATE EC. Okay, so what they are asking, you need to find out the value of coefficient alpha such that expression will minimize the length of error vector E. What is error vector E? Sir, error vector E is nothing but V1 minus alpha V2. What is V1? V1 is 120 minus alpha V2. What is V2? 213. So what is the error vector you are getting? 1 minus 2 alpha, 2 minus alpha, 0 minus 3 alpha. This is the error vector you are getting. That means the error vector that I am getting is 1 minus 2 alpha I cap plus 2 minus alpha j cap minus 3 alpha k cap. What is the length of this vector? Length of this vector, you can write down in this manner. Length of this vector will be under root 1 minus 2 alpha whole square, 2 minus alpha whole square plus 3 alpha whole square. Say yes or no. You need to minimize this. You need to minimize this. You need to minimize this. Minimize for which value of alpha? For which value of alpha this will be minimized? What does that mean? That means let's just say this function is f. I am calling this function as f of alpha. So what I will do? I will simply differentiate it with respect to alpha and put that equals to 0. From here I will get the value of alpha. I need to minimize it, no? So just simply differentiate it. So 2 into 1 minus 2 alpha plus 2 into 2 minus alpha plus 2 into 3 alpha. Is that differentiation correct? No. 2 into 1 minus 2 alpha multiply with minus 2 as well. Here I forgot about minus 2, and here multiply with minus 1 as well. Just doing the differentiation, nothing else. Just I have done the differentiation. Differentiation I am doing, nothing else, right? And I am ignoring this under root. Why is that so? Because if this, whatever that is written inside, if that is minimum, then surely under root minimum will be minimum only, no? So I am ignoring this under root. Okay. So 1 minus 2 alpha whole square plus 2 minus alpha whole square plus 3 alpha whole square. So I am just differentiating it. Differentiation is not a difficult task. 2 will come in front, 1 minus 2 alpha. Then differentiation of minus 2 alpha will be minus 2. Then 2 minus alpha whole square, the differentiation will be 2 into 2 minus alpha. Differentiation of minus alpha will become minus 1, and 2 into 3 alpha, and differentiation of 3 alpha will become 3 only. will be equals to 0. Understandable? So this is the differentiation that we have done. This will be minus 4 plus 8 alpha minus 4 plus 2 alpha plus 18 alpha equals to 0. (28 alpha equals to 8). So alpha equals to 8 by 28. So answer is 2 by 7 is the answer that we are getting. 2 by 7 is the answer. Is that understandable to you? And what is the minimum value of alpha? What is the minimum value of what is the minimum value of the length? If they are asking, then you just put this value of alpha here and you will get the minimum value of length as well. But they are just asking that you find out the error vector and then minimize it. At what value of alpha you will get the minimum value of the error vector. So the value of alpha is coming out to be 2 by 7. How did we get to know? I just took the magnitude and then I differentiated it, put that and I am putting it equals to 0. Understandable? So the value is coming out to be 2 by 7. Let's go to the next question. Consider two vectors. Magnitude of the vector component A that is orthogonal to vector B in the plane containing A and B is. Think about this question and try solving it on your own. Again, gate QIQ. Again, it is gate question only. What they are asking? Magnitude of component of vector A that is orthogonal to vector B in the plane containing A and B both. That means let's just say this is my plane. Let's just say this is my plane. This is my plane. This is my plane. Okay, this hand is my plane. This is my plane. This is my plane. In this plane, there are two vectors, vector A and vector B. They will be making some angle with each other. This is your vector A and this is your vector B. Vector A and vector, this is your vector A and this is your vector B. Vector A, vector B. You need to find out the component of vector A. What all are the component of vector A? A will have, sir, two components. One component would be A cos theta and other component would be, sir, A sin theta. Sir, A cos theta will be in the direction of B and, sir, A sin theta will be perpendicular to B. So whenever you read, sir, orthogonal to vector B, so it will feel like that, sir, I need to do the cross product, orthogonal to vector B. But they are saying they should be in the same plane. That means this is the vector that they are asking, or they are asking about the magnitude. That means this is something that they are asking about. This is something that they are asking about, that you need to find out the component of A which is perpendicular to B. Component of A which is perpendicular to B. Component of A which is perpendicular to B. That means they are talking about A sin theta. So you are supposed to find out A sin theta, where theta is the angle between A and B. So what is your answer? Your answer is nothing but A sin theta. This is your answer, where theta is the angle between A and B. Where A is the magnitude of A, right? The angle between A and B. Vector A and vector B. Is that understandable to you? Component of A orthogonal to B in the plane containing AB both. Understandable? So let's find out. First of all, I need to find out the angle between A and B. What I need to find out? I need to find out the angle between A and B. So do I have the page? No. I need to add a page. So A vector dot B vector would be equals to AB cos theta. So A vector dot B vector, 15 minus 7 plus 12. A vector dot B vector I am doing. No, 5 into 3, 15. 7 into minus 1 will be minus 7. 6 into 2 will be 12. 15 minus 7 plus 12 will be equals to magnitude of A. That would be 25 plus 49 plus 4. That would be 25 plus 49. 25 plus 49 plus 4 and then take its under root, 8.83. Magnitude of A is coming out to be 8.83. Multiply with magnitude of B. Magnitude of B will be 9 plus 1 plus 36, take under root 6.78, 6.78 cos theta. So 6.78 multiply with 8.83 and take the reciprocal, multiply with 20. And then take the cos inverse. So value of theta you are getting is 70.49 degree. This is the value of theta you are getting. So what is the component? What is the component? Answer is a sin theta. And what is the magnitude of a? Magnitude of a is 8.83 sin 70.49 degree. Multiply with 8.83. So answer is coming out to be 8.32. 8.32 is the answer. This is the answer that we are getting. 8.32 is the answer that we are getting. That's it. Okay. So was it an easy question? Yeah, it was a good question. But yeah, some concept was also involved, that you need to find out the vector which is perpendicular to B, not perpendicular to A. You need to find out the component of A. So component of A which is perpendicular to B, that means you are supposed to find out A sin theta. Understandable? Okay, so A sin theta we have find out. Job done. So this was your basics of vector algebra. Here your basics of vector algebra is completed. Basics of vector algebra is completed. This was your basics of vector algebra. Now what we are going to see? Now we are going to see that some prerequisites of vector calculus, whether it is differential vector calculus or it is integral vector calculus. So now these are the prerequisites of vector calculus. This was your basic vector algebra. Very basic question we were solving here, right? And I told you that even in the gate examination, this is a gate PYQ, right? This is also a gate PYQ. This is also a gate PYQ. All are gate PYQs only. So in gate, this is also a gate PYQ only. So in gate examination, questions are asked from basic vector algebra. So that's why I wanted to teach some concept and some questions as well I wanted to deal. This is also a gate PYQ. So when I checked the gate PYQs, I noticed that when we study vector calculus, we directly start from the differential vector calculus. We all directly start from the del operator, gradient, divergence, curl. This is what we start from. But basics of vector algebra also there are some questions. So roughly around 20-25 questions were there. So what I did was I taught these concepts, and now you will be able to solve all the basic questions. And now we will move towards the prerequisites or basic understanding of vector calculus from here onwards. So we will talk about open line, closed line, because these terms will be used again and again. When we will study about integral calculus, I will say calculate the open line integral, calculate the closed line integral, calculate the open surface integral, calculate the closed surface integral. So these terms will be used again and again, and people don't understand the difference between them. So we are going to understand the difference between open line, open surface, closed surface. What is the difference? And then we will study about some more prerequisite we will see. We will revisit the coordinate system as well, right? We will move in a particular direction. All these points we need to see, which will work as a prerequisite to vector calculus. Okay, prerequisite to vector calculus. So we will get started. Let me take a break. I will drink some water and then I will come back and we will get started with the open line and closed line. What is the meaning of open line and what is the meaning of closed line? Yeah, welcome back. So let's understand the meaning of open line and closed line. Okay, so these terms will be highly used when we study about integral calculus. Okay, when we study about vector integral calculus, these terms will be highly used. So what is the meaning of open line? Open line means the starting and ending points are different. Let's just say I am moving from point A to point B. I can move along any path, right? I can move from point A to point B in this manner. I am moving from A to B. So I am moving from A to B. I am not coming back from B to A, right? I am not coming back from B to A. This is the path that I am following, A to B. Or let's just say what I did. I went from A to B. I went from A to B. Then I went from B to C. Then I went from B to C. Then from C to D. This is the path I followed. B to C. Then C to D. Then C to D. Then let's just say from D to E also I went. From D to somewhere E. Let's just say this is your E. From D to E also I went. But I never reached back to the same point, right? I started from A to B, B to C, C to D, D to E. I never came back to the same point. So this will also be known as open line. Open line means this, let's just say this particular pan is not having any width. This is a simple open line. You can go from A to B. That's it. You cannot come back from B to A. But what if I went from A to B through this path, A to B through this path, and then A to B through this path, and then came back from B to A through this path. So what it is making? It is making a closed line, right? A to B, then again B to A, or first A to B, then B to C, then C to D, then D to A again. Started from A, went from A to B, then B to C, then C to D, and then D to A. Understandable? Or it could be somewhat like this. It could be somewhat like this. That you started from point A, you moved around the circle, and you again came back to point A only. So what is the meaning of closed line? It will make a closed line. You will start from a particular point and you will reach back to the same point only. So this is the meaning of a closed line. Is that understandable to you? Now we will see the difference between closed line and open surface. What we are going to see? Closed line and open surface. So already we have understood about closed line. This is a closed line. This square could be a closed line, right? This triangle could be a closed line. These are your closed line. So we have already understood the meaning of closed line. What is the meaning of closed line? That you will start from a particular point A and you will again reach back to the same point A only. You will start from a particular point A and you will again reach back to the same point A only. You will start from a particular point A and you will again reach back to the same point A only. This is the meaning of closed line. Now what is the meaning of surface? First of all, you let me know what is the meaning of surface. Sir, this is a surface. This is a surface. So this is a surface, this is a surface. So this is your open surface, right? This is your open surface. This is your open surface. What is the difference between a closed line and open surface? This is your closed line, and this is your open surface. What is the difference between these two things? Here my matter of concern was moving on this particular line. Here my matter of concern was moving on this particular line. But here my matter of concern will become this particular surface S. When I am moving on this particular line, let's just say this is the line I am moving on. Let's just say this is the line I am moving on. On this particular line I am moving. Can you see this wire? I am moving on the edge of this wire. So is this wire enclosing some area? Yes sir, it is enclosing some surface area. This much surface area it is enclosing. Which surface area? Inside this some surface area is there. This much surface area it is enclosing. But if I put my hand here, do I get some material? If I put my hand here, do I get some material? There is no material inside. No, it is enclosing this area, but there is no material inside. No material is there. No material is there. No material inside. But what if I talk about this particular surface? This particular surface. So if I am putting my hand here, am I getting some material? Absolutely, sir. So yes, there is some material present. Yes, there is some material present. If I am putting my hand here, do I get some material? Yes, I get some material. If I place my hand here, do I get some material? Yes, I get some material. So here my matter of concern will be moving on the line, but here my matter of concern will become this surface area. So this is known as open surface. So on a crude level, on a top level, what you can say, sir, a closed line is a circle, and an open surface is a disc, and an open surface is a disc. Here I need to fill the color. An open surface is a disc. Closed line is a circle, open surface is a disc. And here these are simple arc. This is a simple arc. Arc means you are going from point A to point B. This is a simple arc. So arc was open line, then closed line was a circle, and open surface was a disc. Now we will see the difference between open surface and closed surface. So you have already seen open surface, right? This is an open surface. This is not an open surface as of now. Now it will become an open surface. This is an open surface. This is an open surface. Now what I will do? I will take 6 open surfaces. What I will do? I will take 6 open surface and I will make a cube. What I am doing? I am making a cube. I am making a cube. This is the cube I have made. But all of them are one open surface. That means here there is some material, right? Here there is some material. Here also there is some material present. Here also there is some material present. Here also there is some material present. So all the walls are having some material. No, let us say this I am talking about. Inside there is nothing. But this is one wall, this is another wall, this is another wall, this is another wall, this is another wall, and this is another wall. So 6 walls are there. All are having some material here. So all are one open surface. Is this one open surface? Yes. 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 Open surface, open surface. 6 open surface are enclosing a particular volume. Right? They are enclosing a particular volume inside. So open surfaces combined, what did they make? They made a closed surface. They made a closed surface. So what it is? It was a cube. It was a cube. If I talk about a sphere, what I am talking about? I am talking about a sphere. If I talk about a sphere, sphere. What is the meaning of sphere? This is a sphere. So there is a material present, and is it enclosing any volume? I am asking you, is this open surface enclosing any volume? What is the meaning of open surface? Open surface means simply this paper. Does it enclose any volume? No, this is not enclosing any volume. But what if I make it somewhat like this? I rotate it and I make a cylinder. Upper side as well there is something, downward side there is something, and on the curve as well there is something. That means it will enclose some volume now, no? So similarly, this is the sphere that you are having. Is it enclosing some volume? Yes, inside it is enclosing some volume. So this was your disc. This was your disc, which was not enclosing any volume. But what this is? This is your closed surface, which will include some volume. So in 2D it will be tough to show. So this is how I am showing a sphere. So this is your sphere, which is a closed surface. It will include some volume. It will enclose some volume. So did you understand the point? Started with open line, starting from a particular point, reaching to a particular point, not coming back to the same point. If you are coming back to the same point, working on a particular line, that means this is a closed line. Now what is the difference between closed line and open surface? Closed line means you are working on a particular line. And what is the meaning of surface? Surface means you are interested in the surface area. That means there is some material present inside. You are interested in this particular surface area. So this is the meaning of open surface. Now what is open surface versus closed surface? So open surface was a disc. Now using these disc, can you make a sphere? If you are able to make a sphere, that means the outer surface area, this particular surface area is enclosing some volume. So this is known as closed surface. Using the open surface, using these cubes, sorry, using these square, I can make a cube, right? I should not call it square. I should call it rectangular sheet, right? I should call it a square sheet. Better, I should call it square sheet. So using these square sheets, can I make a cube? Yes, I can make a cube, and that cube will enclose some volume. This cuboid, although it is a cuboid, it is enclosing some volume inside. So if it is enclosing some volume, that means it will be closed surface. Is that understandable to you or not? So if during the lecture of integral calculus, if I ask you calculate the open line integral, will you be able to understand that, sir, I will be moving along the curve C1. I will be going from A to B. Open line integral. If I ask you to calculate the closed line integral will be shown by this integral sign and then one closed curve I will make. Closed line integral means you are moving along the curve C1, you are moving along the curve C2 only, but you are coming back to the same point. You are going from A to again coming back to A to B, B to C, C to D, D to A. So this is how closed line integral is shown. This is how open line integral is shown. What about open surface? Open surface integral is shown by this double integral and S is written, where the surface, this is your surface S. And how your closed line surface integral will be shown? Closed line surface integral will be shown by this. Is that notation clear? Notation is completely clear. Closed line surface integral, I should not say closed line surface integral, I should say closed surface integral. Open surface integral. This is your open surface integral. Closed line integral, open line integral. Open line integral simply A to B. Closed line integral A again back to A. Open surface integral, that means it is not enclosing any volume. Closed surface integral, it is enclosing some volume. That's it. Now let me know, is it enclosing any surface area? No surface area enclosed. Is it enclosing any surface area? Yes. Although there is no material, but it is enclosing some surface area, no? So it will enclose some surface area. Enclosing surface area. Enclosing some surface area. Although there is no material inside. I told you, you simply take a wire like this. There is no material inside. You are simply taking a wire. There is no material inside, but it is enclosing this much surface area, no? This much surface area. It is enclosing this much surface area, right? Understandable? So these terms will be highly used. So that's why we have understood here. Open line, open surface, closed surface. Understandable? So this is the example. Arc is an open line, closed line is a circle, disc, that means there is color inside. So disc is a open surface and sphere is a closed surface. Understandable? So this is just a comparison. Next, let's revisit the coordinate system. Do you remember Cartesian coordinate system? You need to reach to this point P, x, y, z. How will you reach to this point P? Sir, if I need to reach to this point P, what I will do is that I will move for x in the x-axis, then I will move for a distance y in the y-axis, then I will move for a distance z in the z-axis. So this is how I will reach to the point P, x, y and z. This is how I will reach here. So if I move a small distance, in the direction of x, how I can write down this distance? What I am saying, moving a small distance, or I should say moving a small length in the direction of x, moving a small length in the direction of x, will be equals to what? That will be equals to dx I cap. Next, moving a small length, like what is the direction? Direction will be I cap, right? And how much distance you are moving? You are moving a small length. You are moving a small length in the direction of y. What that would be given by? That I am moving a small length in the direction of y. That will be given by dy j cap. And if I am moving a small length in the direction of z, that will be given by dz k cap. If I am moving a small length in the direction of z, it will be given by dz k cap. So this is on the x-axis, y-axis and z-axis. If I am moving along the direction of zy axis, or I should say zy plane, what I am saying, moving a small length in zy plane. What is the meaning of moving in zy plane? That means you are moving in the direction of y as well, you are moving in the direction of z as well. So how you can write down the small length? I can write down the small length as dz az cap plus az means here I will write down k cap, dz k cap plus dy j cap. Say yes or no? Right? You are moving in zy plane. That means you are moving in the direction of z as well, you are moving in the direction of y as well. So similarly, moving a small length in xy plane, what that would be? In xy plane, what will be your xy plane? This will be your xy plane, right? That means you are moving in the direction of x as well, you are moving in the direction of y as well. That will be dx I cap plus dy j cap. And if I am moving a small length in 3D space, what that would be given by? So that would be given by, that means 3D space means you are moving in the direction of x as well. That means this distance we are talking about, that you are moving in the direction of x as well, you are moving in the direction of y as well, and you are moving in the direction of z as well. So you are moving in the direction of x as well, you are moving in the direction of y as well, and you are moving in the direction of z as well. This is your moving a small length in 3D space, dx I cap plus dy j cap plus dz k cap. So previously we know that in the integral calculus only we have studied moving a small length in x will be dx, moving a small length in y will be dy, moving a small length in z will be dz. This we have already understood, right? So since we are studying vector now, so along with that we need to put up the direction as well. Okay, and we will take up the positive direction only. Someone would say that, sir, what if I move here? That means you are moving dx minus I cap, All as of now we are moving in the dx plus I cap, right? And what is the volume in Cartesian coordinate system? What is the volume in Cartesian coordinate system? Moving a small length in x, moving a small length in y, moving a small length in z. This we have already understood in the integral calculus, right? So basic prerequisite already we have seen in the integral calculus when we studied about calculus of real variables. So this is the volume that we will write down. Understandable? Let's talk about cylindrical coordinate system. So in cylindrical coordinate system, you need to reach to this point P, which is rho, comma, phi, comma, z. How will you reach it? Sir, I will move for a radial distance. I will move for a radial distance rho, making an angle of phi with x-axis in the anti-clockwise direction, and then I will move for a distance of z. Then I will move for a distance of z, and I will reach to the point P. So I will move for a distance of rho, making an angle of phi with positive x-axis, and then I will move for a distance of z in the z direction. So this is how I will reach to this point P. Right? This is how I will reach to this point P. Question that I am asking you, that if you are moving in the direction of rho, moving a small length in the direction of rho, moving a small length, first one in the direction of rho, although it will not be highly used, but still in the direction of rho, what that would be? So that would be d rho a rho cap. What is the meaning of a rho cap? That means, let's just say if I am moving, let's just say if I am moving in this direction, let's just say if I am moving in this direction, so what will be the unit vector? The unit vector will be a rho cap. The unit vector will be a rho cap. This is your unit vector a rho cap. If I am moving in this direction, the unit vector will be a rho cap. Moving in the direction of phi, this you should not be telling wrong. In the direction of phi, if you are moving in the direction of phi, how much distance do you move? How much length do you move? Do you remember it or not? How much length do you move? Rho d phi, right? Rho d phi. So if I am moving in the direction of rho, how much length I am moving? I am moving the length of rho d phi. I am moving the length of rho d phi, right? This angle will be d phi. So I am moving the length of rho d phi. This length will be rho d phi. So in which direction I am moving? I am moving in this direction, no? So if I take the tangential component, the tangential component will be somewhat like this. So this will be your a phi cap direction. A phi cap direction. So rho d phi a phi cap direction. That means you are moving in the direction of phi. And if I move in the direction of z, then this is how I will move. In the direction of z, how much do I move? In the direction of z, how much do I move? dz az cap. So did you see the coordinate system? This was your a rho cap, then perpendicularly a phi cap, and then perpendicularly both of them are in the same plane. They are perpendicular to each other and both of them are same in the same plane. Moving in the direction of rho, a rho, then moving in the direction of phi, a phi, both of them are in the same plane, although they are perpendicular to each other. Then dz, which is in the new plane. I should not say plane, it is here. dz is going upward. Is that understandable to you? So from here I can say that rho cross phi, a rho cross a phi will give you az. Say yes or no? Rho cross phi would give you z. Not very important, but again the same thing we can do here. No, I cap cross j cap gives you k cap, right? I cross j, this is your I cap, this is your j cap. So I cross j, use the right hand rule. I cross j will give you k cap. So similarly, rho cross phi is giving you az cap. So that's why rho phi z, I j k, x phi z. Here rho phi z, rho phi z. This is how the coordinate system is given, right? And what is the volume is given? What is the volume? So the volume given is rho d rho d phi dz. This also we have already seen. Understandable? Now someone would say, sir, what if I move in the rho phi plane? Then the distance would be d rho a phi cap, sorry, d rho a rho cap plus rho d phi a phi cap. What if I move in the phi z plane? Then the distance would be rho d phi a phi cap plus dz az cap. If I move in the rho z plane, then what will be the distance? Sir, the distance would be d rho a rho cap plus dz az cap. And if I move in 3D space, small length in 3D space, small length in the 3D space, so that would be d rho a rho cap plus rho d phi a phi cap plus dz az cap. This will be the small length in 3D space. 3D space. Understandable? Sir, here you are not talking about surface area, right? Here also you did not talk about surface area. We will talk about it. Okay, we will surely talk about it. But surface area deserves a separate topic, right? We will not deal it in between, so that will be a separate topic. So that's why we will deal it later on. Okay, so volume and length we are talking about. Surface area we will talk about it. Similarly for spherical coordinate system, if I need to reach to this point P, how will I reach it? Sir, I will reach it making an angle of theta with positive z axis in the downward direction. In that downward direction, making an angle of theta with positive z axis in the downward direction, and I will walk for a distance of r. How this r will be taken? Sir, this r will be taken in a manner that if I take its projection on the xy plane, then it should be making an angle of phi with x axis. So how the coordinates are given? R comma theta comma phi. This is how the coordinates are given. Now first of all, you let me know what is the direction of r. If you move a small distance in the direction of r, if you move a small distance in the direction of r, that will be, this is the direction of r. If I am moving in the direction of r, if I move in the direction of theta, then this is how I am moving. No, direction of theta, direction of theta, direction of theta is like this, coming downward. So if I want to make this vector, then just I need to take the parallel vector. So this will be the direction of a theta. Are you able to understand this point? Direction of theta is going downward like this. So here the direction is this. This is your a theta gap. So if I want to make at this particular point, then what I did, I just took a parallel vector. So this is your a theta. And what about a phi? A phi. A phi is going inside. A phi is going inside. A phi is going inside. So they are in the same plane. AR and a theta, they are in the same plane, but a phi is going inside. A phi is going inside. Visualization is difficult, but hopefully you are able to understand that a phi is going inside. A phi is inside. Are you able to understand this point? So a phi is going inside. They are perpendicular to each other. So rho phi z. So from here, what did you understand? That AR multiply with a theta will give you a phi. R comma theta comma phi. This is the direction of r. This is the direction of theta, and this is the direction of phi, which is going inside. So they are in the same plane. AR and AR, this is your AR, right? This is your AR, and this is your a theta. Where phi is going? Phi is going inside. So r cross theta, phi will be inside only. So I will write down, this will be my a phi. Is that clear to you? A phi means that it is going inside, no? So inside is shown by dot. I hope you know this thing, that this is going inside the screen, and this is, oh sorry guys, going inside is shown by cross. R cross theta, going inside is shown by cross. So going inside is shown by cross. Going inside is shown by cross, and this is coming towards you. So this is going inside. So a phi is going inside. Why is that? So you can understand. A rho, a theta, and a phi inside. So rho cross theta is phi. Understandable? Now moving a small length. So let's start moving some small lengths. Just 1 second. Yes. Now start moving a small length in the direction of moving a small length in the direction of r. In the direction of, how we write, yeah, in the direction of r. In the direction of r. So what will be that small length? So that will be dr AR gap. Now next, you should not be messing it up. I am asking you, moving a small length in the direction of theta, how much do you move? Let me know what is the distance. In the direction of theta, how much do you move? This we have already understood. This is your theta. What will be your d theta? So this will be my d theta. Theta, and this angle will be d theta. So how much do I move in the direction of theta? I move in the direction of theta, the length of r d theta. I am talking about the length, not the angle. So here we need to talk about the length. So in the direction of theta, you move for r d theta length, and in the direction of phi, how much do you move? In the direction of phi. In the direction of phi. So if you want to move in the direction of phi, so you will move for angle of d phi. You will move for angle of d phi, but how much distance? The distance would be, sir, this is r, This component will be r cos theta, this component will be r sin theta. So you move for a distance of r sin theta d phi. You move for a distance of r sin theta d phi in the direction of phi. So all these things we already remember. In the direction of r, dr. In the direction of theta, r d theta. In the direction of phi, r sin theta d phi. Understandable? And eventually, what is the volume that comes out to be? Always I have asked you to remember these volumes and all. So volume will come out to be r square sin theta dr d theta d phi. So if you don't remember this direct result, how do you remember? In the direction of r, dr. In the direction of theta, r d theta. In the direction of phi, r sin theta d phi. So r square sin theta dr d theta d phi. That's it. This is the volume. And if I need to write down the differential length, what is the meaning of differential length? I need to write down that differential length. What do I mean by differential length? Differential length simply means, sir, if you are moving in that 3D space, so what length you will write down? If you are moving in the 3D space, that means you will walk in the direction of r, you will walk in the direction of theta, and you will walk or you will move in the direction of phi as well. In the direction of phi, r sin theta d phi a phi cap. This is your dl vector. Understandable? In the direction of r, dr. In the direction of theta, r d theta. In the direction of phi, r sin theta d phi. Understandable? Job done. So this is your spherical coordinate system. This was your cylindrical coordinate system. This is your Cartesian coordinate system. As of now, you might be feeling that, sir, what we are studying, but slowly it will make sense. All these things, open surface, closed surface, everything will be helpful when we study about integral calculus. They will be very, very, very helpful. Understandable? So in one video only, I thought that first we should cover all the prerequisite, then we will think of something else. Right? So all the prerequisite will be covered. When we start integral calculus, you will feel like that, sir, I already know everything. Is that clear to you? Because these are the important points. In the integral calculus, in the vector integral calculus, people will struggle in these directions and all. So if we are studying it as of now, then you will not be struggling there. Now let's talk about the surface area. Now the question would be that, sir, do surface area is a vector quantity? Is surface area a vector quantity? What is the question? Is surface area a vector quantity? Yes, it is a vector quantity. Someone would say, sir, what is the surface area of this? Let's just say the surface area of this is 5 centimeter square. The surface area is 5 centimeter square. So, sir, what do you mean by direction? So, what is the meaning of direction? Let's just say these are 4 lines. 4 lines. These are 4 lines. And this is my surface. If I keep my surface like this, then all 4 lines are cutting my surface, no? All four lines will cut my surface. All 4 lines will cut my surface, right? Now, if I keep the same surface, what is the surface area now? 5 centimeter square. If I tilt it like this, what is the surface area now? Again, it is 5 centimeter square only. But now, how many lines will cut? Sir, only 2 lines will cut, sir. These 2 lines will not cut. Only 2 lines will cut. And now, if I keep my surface area like this, then how many lines will cut? 0 lines will cut. What do you understand by this? Surface area is remaining same. 5 centimeter square, 5 centimeter square, 5 centimeter square. But if you change the orientation of this surface area, when this was the surface area, the field lines, what is the meaning of field lines? That we will see. All the field lines are cutting. All these lines are cutting. When you tilted, 2 lines are cutting, 2 lines are not cutting. When you tilted it more, no line is cutting. Right? That means there is a importance of the orientation, no? That means there is an importance of the direction. So direction of surface area, let's just say this is a particular surface area that we are having. This is a particular surface area we are having. This is a plane we are having. This is a open surface that we are having. So direction of this open surface is given by perpendicularly outward or perpendicularly outward or perpendicularly downward. Are you able to understand this point? It is normal to the surface. That means the direction would be either upper side. Normal to the surface means it could be downward as well, no? So perpendicularly outward or perpendicularly downward. So this is the direction of a surface. This is the direction of a surface. It could be given by an cap or it could be given by minus an cap as well. So let's just say there is a random open surface like this. There is a random open surface like this. Random open surface like this. If I ask you, what is the direction of this surface area? What is the direction of this surface area? Then you will say, sir, direction of surface area will be perpendicularly outward or perpendicularly inward. So this would be either, so the surface area is placed like this. So either it will be perpendicularly outward or perpendicularly inward. So either an cap or minus an cap. So this we talked about open surface. We are talking about open surface now, right? This is an open surface. Now this is an open surface. Now let's talk about closed surface now. What do you mean by closed surface? What do you mean by closed surface? That sir, here there is some material, here also there is some material. In that manner, sir, all these closed surfaces are there and we have made a cube. So here there are, sir, 6 open surfaces. 6 open surfaces combined have made a closed surface. 6 open surfaces have made a closed surface. Have made a closed surface. Now let's just say this surface is S1. Which surface is S1? This surface is S1. Now I go to S1 surface and I ask you, what is the direction of your surface area vector? What is the direction of your surface area vector? So what this surface will say? What this S1 will say? Sir, it would be either outward or it could be same inward as well. There are 2 directions possible, no? Sir, either it could be outward here. Let's use a different color pen. Either it would be, sir, outward, or sir, it could be inward as well, or it could be inward as well, or it could be inward as well, right? Either it would be outward or it could be, sir, inward as well. But since it is a part of a closed surface, since what is written, if a surface is a part of closed surface, then the direction of surface area vector is always taken perpendicularly outward to the enclosed volume. That means the vector should not be coming inside the volume, it should be outward to the volume only. That means it should be focusing outward. So this will be the direction of S1. The direction of S1 will be outward. Let's just say I make a coordinate system like this. This is your x, this is your y, and this is your z. Okay. So this is your ax cap, this is your ay cap, and this is your az cap. So now let me know for S1 what is the direction. For S1 what is the direction? Did you understand this point? I have made a coordinate system like this. This is your ay cap, this is your ax cap, and this is your az cap. Understandable? Did you understand this point or not? This is your ay cap, this is your az cap, and this is your ax cap. Now for the surface S1, this is my surface S1. So for the surface S1, what is the direction of surface area? What is the direction of surface area? That is ax cap. For the surface S2, this is the surface S2. Which is surface S2? This is surface S2. Which is surface S2? Where is this? This is your surface S2. For the surface S2, what is the direction of surface area vector? So direction of surface area vector could be, sir, either it goes outside or it could go inside as well. But since it is a part of a closed surface, it has to be outward only. So for S2, sir, it will be minus ax cap. For S2, sir, it would be minus ax cap. What about for S3? For S3, sir, it will be pointing outward. So, sir, for S3, it will be plus ay cap. For S3, sir, it will be plus ay cap. What about for S4? What is S4? The downward one is S4. S3 was this upper one. So, outward, ay cap. S4 is this downward one. So, downward below. S4 is this downward one. So, it will be, for S4, it will be minus ay cap. Right? This is plus ay cap, this is minus ay cap. What about for S5 and S6? So, let's just say S5 is the previous one. S5 is the backward one. S5 is the backward one. This is the backward one. So, it will be outward, right? So, the direction would be outward like this. For S5, it will be outward like this. So, for S5, it will be minus az cap. And what is S6? This is S6. So, S6 will be directly outward like this. So, for S6, this will be the direction. This is your S6. For S6, the direction would be az cap. Is that clear to you or not? So, this is the part of a closed surface. The direction is outward, 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 direction is outward. So, always you need to take the outward direction. Say yes or no. Is that clear to you or not? So, if your open surface, if a particular open surface is a part of a closed surface, if a particular surface area is a part of closed surface, then the direction of surface area vector is taken perpendicularly outward to the surface, or you can say it will be directed outward from the enclosed volume. Directed outward from the enclosed volume. Directed outward from the enclosed volume. That means it should not be directing inside the closed volume. Like for S1, it should be directing outward in this manner in the AX cap direction. For S3, what is S3? S3 is the upper part, so pointing towards AY cap. For S4, downward part pointing towards minus AY cap. For S5, pointing towards minus AZ cap. For S6, pointing towards plus AZ cap. Understandable? Completely understandable, sir. Now, what we need to do you remember this thing? What I want you to remember? Let me take a break, then I will tell what I want you to remember. I want you to remember ds vector. Do you remember this ds vector? Not ds vector, do you remember this ds? That was under root 1 plus zx square plus zy square dx dy. Do you remember this or not? Curved surface area. If z is a function of x comma y, if z is x square plus y square, so how did we give the small surface area? Although we write down the surface area in this manner, the surface area we wrote down in this manner, right? Area we wrote down in this manner, 1 plus zx square, that would be 2x square, 2x whole square. Zx means, what is the meaning of zx? Partial differentiation of z with respect to x. And what is the meaning of zy? Partial differentiation of z with respect to y. So if you partially differentiate z with respect to x, you get 2x whole square plus 2y whole square dot dx dy. And then we used to do the double integral. This is how we used to do the double integral. And this is the surface area we used to write down. So this was our ds vector. No, this was our ds. Not ds vector, this was our ds. Vector we will talk about later on. So this is the value of ds. That means this is the value of small surface area. So value of small surface area was given by 1 plus zx whole square plus zy whole square dx dy. So here what was the scenario? That x and y were free variable. X and y are free variable. They can take any value. X can take value 1, y can take value 1, x can take value 0, y can take value 2. So x and y were free variables and z was dependent. So ds is written in terms of dx dy, in terms of free variables. Let's just say this time my x is a function of z and y. So this time who are the free variables? Z and y are free variables, right? Z and y are free variables. So what will be my ds? So my ds would be 1 plus, this time here z was partially differentiated with respect to x, so x will be partially differentiated with respect to z and x will be partially differentiated with respect to y. And here you will write down dy dz because they are the free variables. Whatever the free variables are there, they will be written here. Next, if your y is a function of x and z, so who are the free variables? Sir, free variables are x and z. X and z. So how will you write down the ds vector? Not vector. Again and again I am saying ds vector because here we need to write down the vector as well. We will talk about the direction later on. As of now, I am only talking about the magnitude. So what will be the magnitude of ds vector? Sir, magnitude of ds vector will be nothing but 1 plus y partially differentiated with respect to x, y partially differentiated with respect to z as well. And then who are the two free variables? Dx, dz. These are the free variables. They are written here. So this is how I can write down the ds. So ds vector will be having the magnitude of ds and the direction of ds. So we are talking about the magnitude of ds. This we need to talk about. This will be talking about when we study about gradient. Okay. So direction of ds vector we will talk about it, but as of now what we are talking about? We are talking about only ds, the magnitude of ds vector. So we will be interested in the writing ds vector. So we need the magnitude. This is the magnitude and this is the direction. So magnitude and direction both we need. So here I have written the magnitude, which is ds. What is the direction? Direction is ds cap. Understandable? Okay. Now the questions are given. What questions are given? that I have written one equation, z equals to constant, x is going from minus infinity to infinity, y is going from minus infinity to infinity. So your first task would be to tell whether this will represent a line or a plane. Whether this is representing it is a line or plane. It is a line or plane. If it is a line, then you write down the dl vector, and if it is a plane, then you write down the ds vector. This is the question. Okay. X is going from minus infinity to infinity, y can take any value, but z is a constant value. Let's just say z equals to 4. Let's just say z equals to 4. So is it representing a line or it is representing a plane? If it is representing a line, then write down the dl vector. If it is representing a plane, then write down the ds vector. This is the question that I am asking you. So this was the first question, second question, then third, fourth, fifth, sixth, seventh. That's it. 7 questions are there. So these 7 questions you need to solve. So let me take a break and then I will come back. We will solve these questions. Okay, so just to make the coordinate system, x, y, z plane you make, x, y, z space you make, z equals to constant is given, no? So let's take this as x, this as y, and this as z. X cross y equals to z. So what we do is that this is your x, this is your y, right? Yeah. So understand now. Let me know whether z equals to constant will represent a line or a plane, or you can say surface. Plane means surface only. It is a line or a surface. So let me take a break and then I will come back and we will discuss this particular point. Okay. Yeah, welcome back. So did you try this one? What it is? It is a line or a plane? It is a plane. Why is that so? Sir, z equals to 4 is constant. Z has to be equals to 4. Z has to be equals to 4. Y can take values from minus infinity to plus infinity. What is the value of where is y equals to minus infinity? This is your y equals to minus infinity. So y can take the value from minus infinity to plus infinity. X can take the value from minus infinity to plus infinity. So x can also go from minus infinity to plus infinity. Y can also go from minus infinity to plus infinity. Right? But z is fixed at 4. So just think about it. Z equals to 4. This is your coordinate system. This is your coordinate system. Z equals to 4 is fixed. Here z equals to 4 is fixed. Z equals to 4 is fixed. You can move anywhere. You can move anywhere in the horizontal direction. Right? So what it will make? It will make a plane only, no? Z equals to 4 is fixed. Rest anywhere you can move. You can go from y equals to minus infinity to plus infinity, x equals to minus infinity to plus infinity. In 2D, this is how we are showing it, but I hope you would have understood that it will be becoming a plane only. Is that understandable to you? Right? So it will become a plane only. So this is a plane which will be spread till infinity. Although only a small portion we have made, but it will be spread till infinity. So this kind of plane would be there. Right? So z equals to 4. This plane is z equals to 4. What is the equation of this plane? Z equals to 4. Like we wrote down the equation of plane as ax plus by plus cz equals to d. So here the value of a was 0, value of b is also 0, value of c has come out to be 1 and value of d has come out to be 4. So z equals to 4 is the equation of the plane. Understandable? Right? So this is a plane. Now what we need to write down? We need to write down the ds vector. ds vector we need to write down. So ds vector will have the magnitude and the direction. So let's talk about the magnitude first. So if you are on this plane, then in which direction are you moving? Sir, on this particular plane, this is your z equals to 4 plane. Sir, on this particular plane, the value of z is fixed. Value of z is fixed. Sir, I am either moving in the x direction, this is the direction of x, or I am moving in the y direction. I am taking a small portion, I am taking a small surface area. On this particular plane, I am taking a small surface area. So either I am moving in x direction, which will be dx, or I am moving in y direction, which will be dy. Say yes or no. This particular length will be dx and this particular length will be dy. So what will be this small surface area? Sir, the small surface area will be nothing but dx dy. Say yes or no. If you are on this plane, so z is constant, either I move in x direction or I move in y direction. That's it. So ds will be dx dy. What will be ds cap? I told you always surface area vector will be perpendicular to the surface. Perpendicular to the surface. Perpendicular to the surface. Perpendicular to the surface. That means either upward or downward. Perpendicular to the surface. That means either AZ cap or minus AZ cap. Perpendicular to the surface. That means it could be either upward or downward. So since it is not a closed surface, so ds could be plus minus AZ cap. Right? So what is the ds vector? Ds vector could be written as dx dy plus minus AZ cap. If plus is required in the problem, if plus is required, I will take plus. If minus is required, I will take minus. So this is your ds vector that you can write down. Say yes or no. Now there is another way of writing this ds. What did you teach us, sir? This is something that you have taught us, right? Now here you let me know. There is three variables z, x, y. There are three variables z, x, y. Z, x, y. Z is constant, isn't it? And on the plane, on this plane, x and y can take any random value. Here x is 1, y is 2, x is 2, y is 1. X is going from minus infinity to infinity, y is going from minus infinity to infinity. They can take any random value. So they are the free variables. They are the free variables. So how will you write down ds? So ds would be written, since they are the free variables, so here dx dy would come. What will come here? Sir, under root 1 plus, sir, which variable is left? Z is left. So zx square plus zy square. So always first determine who are the free variables. So sir, free variables are x and y. This is constant. X and y are free variable. That means you can write down ds as dx dy. Here what will come? The another variable which is z. So zx square plus zy square. What is zx? Zx is the partial differentiation of z with respect to x. And what is zy? Partial differentiation of z with respect to y. What is given? Z equals to constant is given. If you partially differentiate z with respect to x, what is the answer you will be getting? 0. If you partially differentiate z with respect to y, what is the answer you will be getting? 0. So this will become 1 plus 0 square, this will be 1 only. So ds is coming out to be dx dy. Say yes or no. This is your ds. There you go. Okay. And ds vector, this is how we can determine. Although in the next lecture only we will understand how to write down the ds cap. Okay. Here by the geometry it is clear, right? By the geometry you can see that, sir, surface area vector would be either plus AZ gap or minus AZ gap. But we will build up a method as well. Without making the diagram, without making this diagram, you will be able to write down this ds cap. That means you will be able to write down the surface area vector without drawing the diagram. Okay, so we will learn a method which is known as gradient. Okay, so with the help of gradient, you will be able to write down very easily. It will be plus minus AZ gap. That we will learn in the next lecture. But in this lecture, we have to go by the geometry. Okay, let's go to the next question. This is a good question. So you let me know what it will represent. If you have studied integral calculus previously, then you will be able to answer it. Otherwise, I don't know whether you will be able to answer it or not. So what it will represent, whether it will represent a line or it will represent a surface. If it is representing a line, then you need to write down dl vector. If it is representing a surface, then you need to write down ds vector. Everything in terms of x, y, z. Everything should come in terms of x, y, z. Not rho, comma, phi, comma, z. Nothing. X, y, z. Everything in terms of x, y, z. In mathematics, everything we will try to compute in x, y, z only. So let's make the coordinate system. This is your x-axis, this is your y-axis, this is your z-axis. Z can go from 0 to 5. But x square plus y square equals to 4. So if z is 0, then x square plus y square equals to 4. If z is 0, then x square plus y square equals to 4. If z is 1, then x square plus y square equals to 4. If z is 2, then x square plus y square equals to 4. If z is 5, then x square plus y square equals to 4. That means for z going from 0 to 5. What is the scenario here? Here z was 0 and here z is 5. So z is going from 0 to 5, and every time you are making a circle, x square plus y square equals to 4. X square plus y square equals to 4. X square plus y square equals to 4. What does that mean? It is the curved surface area of a cylinder. It is this surface, right? You are talking about this particular surface. You are not talking about the surface downward. You are not talking about the surface upward. You are only talking about the curved surface. Only curved surface you are talking about. That means it is the curved surface area of a cylinder. Okay, tough to take the name. Curved surface area curved surface area. It is the curved surface area of the cylinder. Understandable? I hope it is clearly understandable to you. These kind of diagrams, n number of diagrams we have made till this point, right? From the integral calculus we started. So curved surface area you need to find out this time. So let me know if we are moving on this plane. If we are moving on this plane, are we moving in the direction of x? Yes, sir. Surely, if we are moving on the plane on this plane, we are surely moving in the direction of x. Are we moving in the direction of y as well? Yes, sir. Are we moving in the direction of z as well? Yes, sir. Like here, it was completely clear. No, it would be dx dy only. You don't even need to apply this method. Here it was completely clear, dx dy. Directly, very easily you were able to write down ds vector. But here things are not very clear. Right? So what you will think first? First of all, you will see, sir, x square plus y square equals to 5. This is given, and z is going from 0 to 5. This is given. First of all, you let me know, it is z free variable. Yes, sir, z can take any value from 0 to 5. It is surely a free variable. It is surely a free variable. Z is surely a free variable. It can take any value between 0 to 5. What about x and y, sir? If I say y is free, variable, then x will be dependent. If I say y is 1, x square plus y square equals to 4. If I say y is 1, then x has to be under root 3. If I say y is 2, then x has to be 0. If I say y is minus 1, then x has to be under root 3. Are you able to understand this point? So if I say y is free, then x is variable. If I say y is free, then x is dependent. Or if I say x is free, then y is dependent. Right? But this guy is always free. Z is always free. Z will independently go from 0 to 5. So two cases we are able to make here. So there will be two ways of writing ds vector. There are two possible answers of this ds. Two possible answers. Why two possible answers? Sir, two possible answers because, sir, we will be able to make two kind of cases. Case one would be that your z is free and y is free. zy free and x variable, or x dependent, I should say, not variable, x dependent. X is dependent. Or case 2 would be zx free, y dependent. Right? So let's solve the first case. Two kind of ds vector you can write down. Now first case where z and y are free, x is variable. Z and y are free and x is variable, or you can say dependent. So your ds would be written in terms of z and y are free, no? So it would be written in terms of dy dz. So under root 1 plus xy square plus xz square. Right? What is the meaning of xy? Xy simply means del x by del y. And what is the meaning of xz? Xz simply means del x by del z. What is the value of x is given? X is given as 4 minus y square. X is given as 4 minus y square. Sorry. X square is given as 4 minus y square. So x is given as under root 4 minus y square, but plus minus would also be there. Plus minus under root 4 minus y square. Say yes or no. X is nothing but plus minus under root 4 minus y square. This is your x. Right? So now I need to find out partially differentiation of x with respect to y. What that would be? 1 by 2 under root 4 minus y square, plus minus is already there, minus 2y. Right? So what you will be getting? Xy I will be getting is y plus minus y under root 4 minus y square. Look, here there is plus minus, multiply with minus sign, it will become minus plus. Doesn't matter. Why it doesn't matter? Because eventually you are going to do the square. So here if there is plus sign or minus sign, doesn't matter much. So in the examination I would have taken only the positive sign. X equals to under root 4 minus y square, 1 by 2 under root 4 minus y square, multiply with 2y. So I am getting y upon under root 4 minus y square. Right? What will be the value of xz? Xz means del x by del z. Partial differentiation of x with respect to z. X is not even a function of z. From here you partially differentiate x with respect to z. Constant value. Answer will be 0. So what you are getting here? ds would be written as under root 1 plus y square upon 4 minus y square into dy dz. Right? So what you will be getting here? Under root 4 minus y square, this will become 4 only, divided by under root 4 minus y square dy dz. What you are getting? 2. Now under root 4 minus y square, what that is? That is nothing but x only. 2 by x dx dz. This is your ds you are getting. Under root 4 minus y square is nothing but x only. Right? So 2 by x dy dz. This is the ds you are getting. ds only. Now ds vector. What you need? You need ds vector. ds vector will be given by ds cap. So this ds I already know, which is, this is very important result. ds you are getting is 2 by x dy dz. You send this question to your 10 of your friends who are not studying from here. Out of 10, 9 people will not be able to solve it, because in the examination always we have focused on this particular surface area. That flat surface area we have always focused on, flat or circular. Either they will focus on the rectangular surface area or they will focus on the circular surface area. But curved surface area, till this point in the examination, it is not asked, and surely it is going to be asked. You can write down on paper. I am telling you, in 2027 or 2028, 2029, surely it is coming. They will talk about the curved surface area. What people will think here? That are you moving in the x direction, y direction, z direction? It is curved, no? So you are moving everywhere, right? So for the curved surface area, this is the formula. So this is the answer that we are getting. Now sir, what about the ds cap? So this as of now you don't know. So this you will be able to calculate with respect to gradient. Like with respect to geometry, can you let me know what will be the direction? You can say that sir, direction will be perpendicularly outward. What is this vector then? Or perpendicularly inward as well, sir. I don't know what will be the direction, but sir, it will be somewhat like this. So can you write down this vector? As of now you don't know that, sir, if this is the surface, then sir, how would I write down the perpendicular vector? That I don't know. How would I write down the surface area vector? Sir, as of now I don't know, but later on you will be able to know. Okay, so that you will be able to know when you study about gradient. So this we will be understanding when we study about gradient, okay, which is our next lecture. So in next lecture, after next lecture, you will be able to write down. So as of now, let me write it down. It would be nothing but 2x I cap plus 2y j cap divided by x I cap plus y j cap. It would come out to be x I cap plus y j cap divided by under root x square plus y square, that is nothing but 2 only. So this will be the answer you will be getting. Okay, this will be dx cap, which you will be studying up in the next lecture. Okay, so very simple concept it is. Once you understand the meaning of gradient, you just need to calculate the gradient of the surface, which is x square plus y square minus 4. You just need to calculate the gradient. Gradient would be 2x I cap plus 2y j cap. This is the gradient, but we need to only the direction. So if we need only the direction, that means we need to divide by under root 2x square plus 2y square as well. So which will come out to be 2 will come outward, and this will be 2 only. So answer will be x I cap plus y j cap divided by 2. So this will be your ds cap. So from here, eventually we can write down the ds vector in this manner. In what manner we can write down the ds vector? So the ds vector we can write down. This is ds and then direction of ds. So what answer you will be getting? 2 and 2 will get cancelled out. So 1 by x I cap y j cap dy dz. This is the answer that you will be getting. Okay, this is the answer. This is only method. This is only way 1. This is the first way, right? This is first way, way 1. This is the ds vector that you are getting. How did I write down? First of all, I got 2 by x dy dz. Then I got the direction, which is x I cap plus y j cap divided by 2. So eventually this is the direction and this is the magnitude. So in the direction, this 2 and 2 will get cancelled out. So what is the answer you will be getting? 1 by x I cap plus y j cap dy dz. This is the way you can write it down. Okay, so very, very, very important. It will be surely used somewhere. You don't need to remember it, but again, method should be clear. This is only one method. Other method I should not say method, it is only one way. There could be other way as well. There could be way 2 as well. What will be that way 2? Sir, way 2 would be that you keep x and z as free, y as x and z as free, and y as dependent. Similar analysis, ditto same analysis. Now you should be able to do it on your own. X square plus y square equals to 4. So y would be under root 4 minus x square. So y of x I will have to calculate, that will come out to be x upon under root 4 minus x square, and y of z I will have to calculate, that will come out to be 0. ds could be written as, since they are free, so dx dz, and here what I will write down, under root 1 plus under root 1 plus yx whole square plus yz whole square dx dz. So under root 1 plus x square upon 4 minus x square dx dz. So what is the answer you are getting? 2 upon under root 4 minus x square, which is nothing but y only. So 2 by y dx dz. This is the ds we are getting. Symmetrical answer is there. 2 by x dy dz. So 2 by y dx dz. Similarly, your ds cap will come out to be the same, x I cap plus y j cap divided by 2. So from here your ds vector, what could be the other way of writing down the ds vector? That would be 1 by y x I cap plus y j cap dx dz. So if you need the final answer in terms of x and z, in terms of dx dz, then this will be the way. If you need the final answer in this term, then this will be the way. So we will see the question, we will see where we are more comfortable. If we are more comfortable with this particular answer, then I will go with this answer. If I am more comfortable with this answer, then I will go with this answer. Both of the answers are correct. Both answers are correct. Both answers are correct. Understandable? So this was your second example. This was also a curved surface. How to write down the curved surface area? It is very important, very important, and not taught in a good manner. Okay, usually people build up some method or they don't even study it. But we have this formula, and based on this formula we have solved a lot of problems as well in integral calculus, right? There we have just simply integrated it. But here we don't need to integrate, right? Integration we will do, but in the next lecture. Not in the next lecture, next to next lecture, when we study about vector integral calculus, there we will do the integration. What do you think what it is? This is also a surface only. First of all, you let me know, was it a closed surface or open surface? Was it a closed surface or open surface? Look, when I talked about that this is the curved surface area, I did not say it is closed from the upper side. I did not say it is closed from the downward side. So in the examination, if they want it to frame as a closed surface, no, so they will write down closed surface x square plus y square equals to 4 and z going from 0 to 5. That means you will have to consider that upper side as well there is a surface, downward side as well there is a surface. In the examination, if they want you to treat it as a closed surface, but if they are only treating the curved surface only, then from the upper side it is open, right? From the downward side as well it is open. So here in this question, if nothing is written, I will treat it as an open surface only. This is the open surface only. Although it is curved, right? It is enclosing some volume, but again it is open, no? From the upper side it is open, from the downward side as well it is open. But it should be closed from everywhere. It should be enclosing the volume inside, right? But it is open here. Here it is open, right? From this side as well it is open. If they want you to treat this particular structure as a closed surface, then they will write down here closed surface. In the language they will write down closed surface. That means you will be able to understand that, sir, here curved area is also there. Along with that, from the upper side as well it is closed, downward side as well it is closed. Understandable? Now you let me know what kind of answer you will be getting here and what kind of structure it is. It is an open surface or closed surface. Clearly you get to know that, sir, it is nothing but a disk. So let's make the coordinate system in this manner: x, y, z. What do you mean by z equals to 0? So z equals to 0. So at z equals to 0 you need to make x square plus y square less than equals to 4. X square plus y square less than equals to 4. So this is your x square plus y square equals to 4. And if I need to make less than equals to 4, what does that mean? That means everything inside it will be included. Everything inside this will be included. That means this whole thing will be included. So this is your x square plus y square less than equals to 4. Say yes or no. So let me do one thing. What I will do is that I will simply make it in 2D only now. I will simply make it in 2D only. Now I know that this is my x-axis, this is my y-axis, and my z-axis is coming outward. Z-axis is coming outward. I already know that z-axis is coming outward. Okay, so let's make it in 2D only, and directly let's fill the color. Now you let me know one thing. If you are moving on this particular plane, is it a plane or a surface? It is a plane or a line? It is simply a plane, right? It is pretty obvious. These things we have already seen. It is a plane. If you are moving on this plane, are you moving in the z direction? Absolutely not. You are moving only in the x direction or y direction. I need to write down in Cartesian coordinate system, not in the polar coordinates. Okay. Someone will say that, sir, I can write down the surface area very easily. It will be, sir, rho d phi. We are not even dealing here. In these terms, we are not even dealing. We are dealing everything in dx, dy, dz. Okay. So if I am moving here, I am either moving in the x direction or I am moving in the y direction. Right. So if I take a small surface area, what that would be? So ds will be dx, dy. And what will be the direction? So sir, this is the surface. So direction will be either coming towards me or going inside. That means plus minus az gap. I just need to take the perpendicular surface vector. Surface vector will be perpendicular to the surface. So either it will be coming towards my side or it will be going inside, right? So it will be plus minus az gap. So what will be the ds vector? So ds vector will be nothing but dx dy plus minus az gap. Say yes or no. Right? You can write down by the other method as well. What does the other method say? This method. First of all, you let me know who are free, who are variable. Z is a free variable here. Z is free. No, it is dependent. No, it is fixed. It is constant. It is fixed. It is not free. Z is not free. X and Y are actually free. On this surface, any value of x and y you can take. If x is 0, y square would be less than 4. If I say x is 0, then the condition is y square would be less than 4. That means y can take value 1 as well, y can take value 2 as well, y can take value 0.1 as well, it can take value 0.2 as well, it can take value 0.3 as well, any value it can take. Right? So if I am treating this as a free variable, then y is also having a lot of option. So y is also free. Here they are not fixed. Here the scenario was x square plus y square equals to 4. X square plus y square equals to 4. That means if I say x is free, x, if I am taking 1, then y has to be under root 3. So if x is free, then y has to be dependent. But here what is the scenario? If x is free, then y is also free to take these many values. So over this surface, y is free to take infinite number of values. So if x is free, if I am treating x as free, on my own I put x equals to 0, then y also is free. Y can also take a lot of values. So here x and y both are free. X and y both are free here. And z is dependent. Right? So what does that mean? That means, sir, ds would be written as under root, z is dependent, no? So 1 plus dependent, or I should say fixed, dx dy. Now z equals to 0, if you calculate zx, that will also be 0. If you calculate zy, that would also be 0. So this will be 0, 0 only. What is the answer you are getting? Dx dy only. So the same answer we are getting here. Okay. In the examination, although if we need to solve the problem, we will solve in terms of polar coordinates only. But as of now, we are writing down in terms of Cartesian coordinate system. In the examination, we will solve with respect to polar coordinate system, right? We will take rho and with the angle of theta. You already know rho d phi, right? Rho going from 0 to the radius, phi going from 0 to 2 pi. These things we have already seen in integral calculus, right? So similar thing we are going to see. But as of now, we are writing everything in terms of x, y and z only. Understandable? Let's go to the next one. X equals to 3, y equals to 4 and z is going from -5 to 5. What it will represent? It will represent a line or it will represent a surface. What do you think? X is 3, y is 4 and z is going from -5 to 5. X, y, and this is your z. X is fixed. That means you need to work for 3 in x direction and you need to work for 4 in y direction. So these 2 points are fixed, 3, 4. But your z can vary. Z can take values from -5 to 5. Z can take these many values. It can take values from or let's use a different color of pen. Z can take any value from -5 to 5. Here Z could be x is 3, y is 4, Z would be -5. Here x is 3, y is 4, Z would be +5. So Z can take any value. So this is the line. This is the line. What it is? It is a line. So now I need to write down the DL vector. So what will be DL vector? So in which direction are we moving? Are we moving in the direction of x? Are we moving in the direction of y? No, x is 3 here. Here also it is 3. Here also x will be 3 only. Here also x will be 3 only. Here also x will be 3 only. Everywhere x will be 3. Here y is 4. Here also y will be 4. Here also y will be 4. Everywhere y will be 4 only. Only thing that is changing is that is z. That means you are moving in the direction of z only. So dz. In the direction of z. Now I don't know whether I am moving like this. Let's just say this is point A and this is point B. So I don't know whether I am going from B to A or I am coming from A to B. I don't know. Right? So here what I will write down? Plus minus AZ gap. Anything could be there. Either I am moving in the plus AZ direction. This is your plus AZ direction. This is your plus AZ direction. And this is your minus AZ direction. So either I am moving in the plus AZ direction or I am moving in the minus AZ direction. I don't even know. If I am going from A to B, then answer would be minus AZ. If you are going from A to B, if you are going from A to B, that means you are actually moving in the minus AZ direction, right? Because this will be plus AZ, this will be minus AZ. And if you are going from B to A, then it will be plus AZ, right? I hope you are not getting with this confused with this AZ, AY, right? I am just habitual. I cap is AX cap, right? And J cap is AY cap, and K cap is AZ cap. It is just that I am more habitual with this guy. Okay, AY, AX, AZ. But I cap, J cap, K cap, in mathematics it will be written in this manner only. I cap, J cap, K cap. But in electronics it is written as AX cap, AY cap, AZ cap. So please don't get confused with this. Okay. Next one, x plus y equals to 2 and z equals to 0. Think about it. What it is. Look, how many fixed variables were there? This was fixed and this was fixed. So two fixed variables were there, right? Two fixed variables. It created a line. One fixed variable, only one fixed variable. It created a surface. Only one fixed variable. Here also only one fixed variable. Here also only one fixed variable. Only one fixed variable, they are free. Here also only one fixed variable which was either x or y, and rest of them are free. But if there are two fixed variable, then what will happen? Is it fixed? Yes, it is fixed. Now if I say x is free, if I say x is free, x is free, let's just say x is 1, then y has to be 1 only. If I say x is 0, then y has to be 2 only. That means if x is free, then y will be fixed. What does that mean? It will also create a line only, which is pretty obvious. You can simply see z equals to 0. What is the meaning of z equals to 0? Z equals to 0 means xy plane. Let's just say this is your x this time, this is your y, and this is your z. Z equals to 0 means xy plane. Z equals to 0 means xy plane. That you need to maintain z equals to 0 and x plus y should be equals to 2. X plus y equals to 2. What kind of graph it would be? This would be the graph. Or I don't even need to make it in only in first quadrant. This is how I can make it. This is the graph of x plus y equals to 2. X plus y equals to 2 with z equals to 0. Z equals to 0 means here everywhere z would be equals to 0. No? At this point, x value is 4, y value is 3, value of z is 0. Here, x value is 3, y value is 4, z value is 0. So, z value will be 0 in the xy plane. So, this is your x plus y equals to 2. What will be this point? X equals to 0, y equals to 2, x equals to 2, y equals to 0. So, what it is? It is a line only. This is also a line. Now, if I am moving along this line, what does that mean? If I am moving along this line, then where I am moving? I am moving either in x direction or in y direction. If I am, look here, x has gone from 0 to 2 and y has gone from 2 to 0. So if I am moving along this line, that means I am moving in x and y direction. I am not moving anything in z direction. Z always remains 0 only. Here better I should have written, what I should have written? 0, 2, 0. Right? 0, 2, 0. And here also 0. Are you able to understand this point? So what will be your DL? So dl would be, I am moving in the direction of x and I am moving in the direction of y as well. This will be your dl vector. Now sir, how did you write down plus ax cap plus ay cap? You don't even know. How will you take plus ax cap? What is the meaning of plus ax cap? This is the meaning of plus ax cap. This is your plus ax cap. This is your plus ax cap. This is your plus ay cap. This will be your minus ay cap. And this will be your minus ax cap. So let's just say if I am moving like this, So if I am moving like this, what does that mean? That means in x direction I am moving here and in y direction I am moving here. That means plus ax minus ay. So I will write down dx plus ax minus ay. Right? Are you able to understand this point? And if I am moving upward, what does that mean? If I am moving upward, so this will be plus ay and this will be minus ax. So plus ay minus ax. In that manner I will write down. So let's just assume we are moving from A to B. So this is how I will write it down. Is that clear? Understandable? Actually, this is wrong. Here, although it is fine as of now that you are writing down dx ax cap minus dy ay cap, it is fine as of now. But when we study integral calculus, no, I will put up a positive sign here only. Why is that so? Because there will be another vector, vector a, and this vector a will consist of x, y coordinates. And if I calculate a dot dl, and then I will calculate the integral. So here I will put the limits, no? Here I will put the limits. So this minus sign and everything, these limits will take care. I will put the limit that x is going from 0 to 2 and y is going from 2 to 0. So y is already decreasing. So here I don't need to put the negative sign. The limits will take care of it. As of now, we are writing down dl vector in this manner, it is fine. But when we study integral calculus, no. So at that time, I will write down my dl vector as dx ax cap plus dy ay cap only. There I will not even think of negative sign. Always positive sign I will write down. Everywhere positive sign I will be putting up. Negative sign I will not be putting up. So there I will give you the reasoning. I will say one thing, that no matter in whichever the direction you are moving, whether x is increasing, y is increasing, x is decreasing, y is decreasing, you don't need to care. The limit will take care of it. X is going from 0 to 2, that means x is increasing, so dx is positive. Y is going from 2 to 0, that means y is decreasing, so minus dy you are getting here. So limit will take care, no, already. So here you put plus dy, limit will take care. But as of now, in this manner, if we are learning that this is the line integral, how will I write down the dl vector? So this is how I will write down the dl vector. Understandable? Okay, let's go to the next one. X square plus y square equals to 4 and z equals to 3. This is also a line. This is also a line only. But there is no meaning of this. So again the same question. Let's change this question and let's make it x plus y equals to 2 and z is going from 0 to 3. Now you let me know whether it is a, because x square plus y square equals to 4, whatever the previous example that was written, that was already a line, and that we already knew that is a line only, right? And we will be moving in the direction of x and y. So dx I cap plus dy j cap, that we will write down. So similar answer, for same answer we would be getting. Here just plus sign I will write down there. Although here also I should write down the plus sign only. But here someone would be thinking, oh, that you are actually moving in the direction of minus ay. So someone would put minus ay here, right? But when we study integral calculus, I will put positive sign here only. So what was the previous example? As far as I remember, it was x square plus y square equals to 4, x square plus y square equals to 4 and z equals to 3. So at z equals to 3, you are supposed to make the circle of x square plus y square equals to 4. So z equals to 3 is fixed. X square plus y square equals to 4. This is the closed line that we are having, right? So if I am moving on this line, that means I am moving in the direction of y and I am moving in the direction of z. In the direction of y, in the direction of z. That means dx I cap plus dy j cap. This will be the dl vector. That's it. But this is an interesting example, that x plus y equals to 2, but this time z is going from 0 to 3. What do you think? X plus y equals to 2 and z is going from 0 to 3. Let's make x, y, z. X plus y equals to 2 with z equals to 0. When z is 0 means this scenario. That means xy plane. X plus y equals to 2. Along with that, I am also putting one condition that x is also greater than 0 and y is also greater than equals to 0. That means I am only talking about first octant. X, otherwise the graph would go somewhat like this. It will just become lengthy, nothing else, right? So if I have put up a condition that x plus y equals to 2, but x is also greater than 0, y is also greater than 0. That means when x is 2, y will be 0, and here z equals to already 0. When x is 0, y will be 2 and z is already 0. But z has to go from 0 to 3. So when z is 1, where will be z equals to 1? This will be your z equals to 1. When z equals to 1, then the same graph you will be getting. When z equals to 2, the same graph you will be getting. When z equals to 3, the same graph you will be getting. So isn't it a plane? Isn't it a plane? Isn't it a plane? Yes sir, it is a plane only, right? Are you able to understand this point? It is simply a plane only. I hope you are able to visualize. This is your coordinate system, right? So coordinate system, if I need to talk about, this is your z-axis, this is your y-axis, and this is your x-axis. So x plus y equals to 2. You see here, this is your x-axis, this is your y-axis, x and y, and this is your z. X plus y equals to 2, then x plus y equals to 2, x plus y equals to 2, x plus y equals to 2, with z going from 0 to 3. That means x plus y equals to 2 line, this particular line, you need to make for z going from 0 to 3. So that means here there will be a plane like this. This plane would be there. Z going from 0 to 3, this plane would be there. So this plane I have made here. Are you able to understand this point? So this is the plane. So it is not cutting on z-axis. I hope you are able to understand. This is not cutting on z-axis. This is a vertical plane like this, right? Let's just say this is your xy plane. So it is a vertical plane like this. It is cutting the xy plane only, not cutting on z-axis. Again you see, this time this is your z-axis, this is your z-axis, this is your x-axis, this is your y-axis. So the plane is here. It is parallel to z-axis. Here is the plane. Here is the plane. This is the plane. Understandable? Now our target is to write down the ds. Our target is to write down ds. So how will I be able to write down ds vector? This is our target. So ds vector will be ds cap. As of now, sir, I don't know what will be ds cap, so I am writing down the ds cap will come out to be I cap plus j cap divided by under root 2. This will be the ds cap. This you will be getting. As of now, you don't know. You will study when you will be able to understand the concept of a gradient. But this ds you write down. Is it free? Surely it is free. Here, one is free, one is variable. If I say x is free, then y will be variable. And if I say y is free, then x will be variable. What does that mean? Way 1. What will be the way 1? That x and z you can treat as free and y as dependent. Right? This is free variable, this is dependent. Understandable? So what will be the answer? ds will be written as under root 1 plus yx square yz square dx dz. What is the value of y from here? Y equals to 2 minus x. So what will be y partially differentiated with respect to x? That will be minus 1. Y partially differentiated with respect to z, that will be 0. Right? Y partially differentiated with respect to z, that will be 0 only, no? Because it is not even a function of z. So what is the answer you will be getting? 1 plus, here minus 1 square will be 1 only. So under root 2 dx dz. This is what you will be getting. So what will be your ds vector? Ds vector is coming out to be under root 2 I cap plus j cap divided by under root 2. Direction I am writing down here, and dx dz. So this and this is getting cancelled out. So your ds vector is coming out to be I cap plus j cap dx dz. Similarly, in the next scenario, this is the way 1, no? This is the way 1. In the way 2, the answer would be I cap plus j cap only. This will be under root 2. This will also come out to be under root 2 only. And in place of dx dz, what you will write down? Dy dz. This is the case of y and z free. if you consider y and z as free, because here in this equation you know that sir, if x is free then y will be dependent, if y is free then x will be dependent. So I am considering y and z as free, then this is the answer. If I have considered x and z as free, then this is the answer. So both answers are correct, only whichever that is necessary in your examination that we will take. And I am telling you 99 out of 100 students will not be able to write down this ds vector. It is very tough for them, because they don't even care about slanted surface. This is a slanted surface. No, slanted surface, curved surface, they never care about. Only two kind of surface they care about. Either it will be this kind of surface, proper square or rectangle, or it will be circular. But slanted, curved, for these kind of surfaces, you know that there is a certain method, sir. Here I cannot comment that if I am moving in the direction of x only or y only or z only, because if I am moving here, that means I am moving in the direction of z as well, I am moving in the direction of x as well, I am moving in the direction of y as well, right? So everywhere I am moving. Only in the first example, sir, it was fixed. Clearly here I was clearly here I was able to see that, sir, z is fixed. I am moving only in the direction of x and y. In another example, in this example, clearly here I was able to see that, sir, z is fixed now. I am moving in the direction of x and y. So here directly I can write down dx dy. But in these kind of examples, in slanted surfaces and all, you can surely you can see one thing. What you can see that, sir, here I am moving in the direction of x as well, I am moving in the direction of y as well, I am moving in the direction of z as well. So now I need to write down the ds vector smartly. I need to see free variables. Based on that, I will be able to write down the ds vector. Understandable? This you will understand when you study about gradient. Next one. Closed cylinder. I told you, no? They will write down closed cylinder. This time it is closed cylinder. What does that mean? There will be upper surface as well and downward surface as well. So you need to write down all possible ds vector. Okay? X square plus y square equals to 4. Z is going from 0 to 5. X should be greater than 0. Y should be greater than 0. What does that mean? That means they are talking about first octant. You need to make a cylinder in the first octant. If this closed cylinder was not written, then you would be able to understand that, sir, at least it is a cylinder. But if they are writing down closed cylinder, that means lower surface will also be there, upper surface will also be there. That means this cylinder is there, this curved surface will be there, upper surface will be there, lower surface will also be there. That means what kind of cylinder you will be getting? X, Y, Z, right? So what kind of cylinder you will be getting? So this kind of cylinder we will be getting. Only in the first quadrant we need to, only in the first octant we need to make it. Right? There you go. This is the curved surface is there. Right, this curved surface is there. So let me know how many surfaces are present. Think about it. In the first octant it is there. How many surfaces are there? 1 surface, 2 surface, 3 surface, 4 surface, 5 surface, 6 surface. How many surfaces are there? What is your answer? 3 surface. 5 surfaces are present. Which 2 surface you forgot about? Sir, upper surface is there, downward surface is there, and sir, curved surface is there. Right? Let's call this one as, sir, S1, upper surface. The downward one, sir, this will be downward surface S2, and then sir, this is curved surface S3. You forget about this surface, no? S4. The XZ plane. Because what you are doing, this is your coordinate system. This is your coordinate system. This is your coordinate system. And here you are putting up a cylinder. Here you are putting up a cylinder. Right? You put up a cylinder here. So when you are putting up a cylinder, you are saying it is a closed cylinder. Since it is a closed cylinder, that means this surface is also there, no? Right? This surface is also there. And this surface is also there. Since it is a closed cylinder, this surface is also there. Right? So you have taken the upper surface S1, S2, sideward surface is also there, S4, and this will be S5. 5 surfaces are there. Are you able to understand this point? Let me make S4 and S5 separately. If you are not able to see, this will be your S4. This is your S4. And this is your S5. This is your S4. And this is your S5. S1 will be the upper one that you are able to see. S2 will be the downward one, and S3 is the curved one. So all surface area we need to write down. This is your X, this is your Y, and this is your Z. Can you write down for S4 and S5 very easily? Sir, for S4, my ds vector will be, first of all, write down the ds. Ds vector will be nothing but, sir, magnitude of ds, direction of ds. What is the magnitude of ds here? Sir, when you are moving on this particular surface, you are moving only in the x and z direction. Say yes or no? We are moving only in the x direction and z direction. X direction and z direction. What will be the direction of surface area? So direction of surface area could be 2. Sir, either it would be outward here or it could be inward here. What will be your answer? Sir, since it is a closed surface, I need to take the direction outward, right? I need to take the direction of a surface area vector such that it is pointing outward of the enclosed volume. It should not be going inside the enclosed volume. This is the enclosed volume, no? So it should be going outward of the enclosed volume. That means the direction would be AY cap here, but in the negative direction. So minus AY cap I will write down. Minus AY cap is the answer. What about for S5? Sir, if I am moving on S5, I can directly see that I am either moving in the Y direction or I am moving in the Z direction. Right? So dy, dz. What do you think? What will be the direction? So direction could be either outward or inward, sir. But inward will you be able to take? No, because it will be coming inside the enclosed volume. It should be going outside the enclosed volume. That means it would be minus AX cap. Minus AX cap. So for S4 and S5, you have already written. Right? So these are the two answers. These are the two answers for S4 and S5. Now S1 and S2, let's write down. S1 and S2. So let's make the diagram yet again for S1 and S2. So this is your S1 actually. S1 is going somewhat like this. And this is your S2. Okay, and here these video points and all we can join, but our matter of concern is upper side is S1, upper side is S1, downward side is S2, and this is your X, Y and Z. This is S1 and this is S2, S1 and S2. So this surface area I need to care about. So here isn't Z fixed. Z is going from 0 to 5. That means here Z equals to 5. On this particular plane, Z equals to 5 is fixed. And here on this particular plane, Z equals to 0 is fixed. Z equals to 0 is fixed. Here on this particular plane, Z equals to 0 is fixed. And here Z equals to 5 is fixed. Say yes or no? You agree to this point? Right? So in which direction you are moving? If you are moving on this plane, if you look closely, in which direction you are moving? Either you are moving in the Y direction or you are moving in the X direction only. You are not moving in the Z direction. On S1 and S2 both, on S1 and S2 both, Z is fixed. Z is fixed. That means you are either moving in x direction or you are moving in y direction. The problem comes when you don't know that z is also not fixed, because the problem will come in the curved surface, because here z is also moving, x is surely moving, y is also surely moving. So everything is moving here, nothing is fixed. But here z is fixed, no? Here z is fixed, here also z is fixed. Everywhere z is fixed. So what does that mean? What will be the, for S1, what will be the ds vector? So ds vector will be, z is fixed, that means you are moving in the x and y direction. Vector I need to write down, that I will write down, don't worry. And here as well, ds vector will be dx dy only. But what about the direction? What about the direction? The direction I need to write down. So what will be the direction? Direction would be outward, and here it would be outward. So for S1 it will be plus AZ gap, and here it would be minus AZ gap, right? Plus AZ gap, minus AZ gap. Now someone would be saying that, sir, what if the surface was like this? If the surface was like this, then also that, sir, you would write down the same ds vector, because sir, here also z is fixed. Let's just say this was x, this is y, this is z. So here also, sir, you will write down the same answer, and outward direction you could have taken. So sir, whether this is the surface or this is the surface, for both of them ds vector is same. Yes, ds vector is same, no issue. For both of them ds vector is same. And forget about vector, this ds value is same both for both of them, dx dy. But after that, what you will have to do, you will have to calculate the double integral, no? So here what will be the double integral? Here double integral, x will be going from 0 to some value, let's just say 2, and y is going from 0 to 3. But in this case, what will be the scenario? In this case, the scenario would be, this is a circular path, no? So what you need to do, you need to take a strip, right? So x will be going from, x will have some constant limit going from 0 to 2, but y will go from 0 to, this will be a variable limit, 0 to 2 minus x square. This kind of limit would be there. So limits would be different. The ds vector for both of them is same. If someone would see this analysis, he would say that, sir, okay, it is a kind of circular path. You have written down that you are moving in the direction of x and y. You have written down your ds vector as dx dy plus az gap, dx dy minus az gap. For S1 plus az, for S2 minus az. So sir, your ds, magnitude of ds was dx dy in both of the cases. What if, sir, the surface was rectangular? Then also, sir, same answer. Yes, the ds value will be same, but the limit would be different here. No, here constant limit would be there, but here the limit would be in the variable limit. One of the limit will be variable. First I will put the variable limit, and then I will put the constant limit. Is that understandable to you? So we will solve these kind of problems. Okay, don't worry, we will solve these kind of problems. So there I will take the vector, I will again take the strip. So you already know how to take the strip and all. You also know one thing, that these kind of problems we never solve with respect to the strip, right? What we do, we convert everything into the polar coordinate system, and we solve these kind of questions with the polar coordinate system, right? I hope you remember it. So everything will be used in the analysis when we study about vector integral calculus. So this is the answer of S1, S2. Now for the curved surface, you write down on your own. For the curved surface, which surface? The third one. This surface I am talking about. Okay, so this surface is S3. So for S3, you write down on your own. So in S3, everything is changing. For S3, X, Y, Z, everything changes. Nothing fixed. Or you can say everything changes. I should not write down nothing fixed. So for S3, what is the scenario actually? For S3, sir, scenario is that here x square plus y square equals to 4. X square plus y square equals to 4. And Z is going from 0 to 5. This is the scenario, right? In S3, x square plus y square equals to 4. If I move on this surface, if I move here on this surface, then I am moving in the direction of x as well, I am moving in the direction of y as well, I am moving in the direction of z as well. Everywhere I am moving, right? So what I will see? Free. One of them I can treat as free, other would be dependent. So what I would do? Z is always free, then there would be two ways. Way one would be keep z and y as free and x as dependent. So what will be the ds vector? ds3 we are talking about, no? So ds vector would be z and y as free and x as dependent. So 1 plus xy square plus xz square dy dz. Understandable? This will be the scenario. Now what is the scenario? X is given as under root 4 minus x square. This we have already solved, no? Why we are wasting time? This we have already solved. This is the scenario. X square plus y square equals to 4, z going from 0 to 5. This we have already solved. What is the answer we will be getting? 2 by x dy dz. So this is the answer we will be getting. Right? Already we have solved. Same example is there, right? Same example is there. Ditto same analysis I am going to do. Right? So x is nothing but under root 4 minus y square. So xy I need to calculate. That will come out to be y upon under root 4 minus y square, and x of z would be nothing but x of z. X of z means partial differentiation of x with respect to z, that will be 0. So here you will put 0, and what is the answer you will be getting? The answer you will be getting is 2 by x dy dz. As of now you don't know how to write down the perpendicular surface vector. You don't know how to write down the perpendicular surface vector. So that vector I am already telling you, it will come out to be xi cap plus yj cap divided by 2, and you will be able to understand it later on in the next lecture. So this will be your ds3 vector, right? And similarly this is way 1, way 2 would also be there. So let's write down the final result on the next page. The final results are somewhat like this. S4, S5 will look somewhat like this. This is the result of S4, S5, and the result of S1, S2. And what about the result of S3? The result of S3. So two possible answers are there. So for S3, two possible answers are there. One answer would be 1 by x xi cap plus yj cap, xi cap plus yj cap dy dz, and other answer would be 1 by y xi cap plus yj cap dx dz. These two answers are possible for S3. This is the surface area vector for everyone, and this is the most complex part of vector calculus that we have done. This is the most complex part. Rest everything is straightforward. Just that you need to know how to write down this ds cap, which is very simple. The most complex part is finding out the curved surface area, finding out this magnitude. Dx dy you have already understood here that a constant part is there, here also constant part is there. It was very straightforward. This other part we have already understood because we have solved a multiple example. Here also we solved in the same manner, here also we solved in the same manner only, here also we solved in the same manner, here also we solved in the same manner. Multiple example we have seen, job is done. Right? Well and good. Okay. Now two small points are there, scalar field and vector field. What do you mean by scalar field? What do you mean by vector field? Very simple concept is there. In one liner if I need to tell, what do you mean by scalar field? It is a function. It is a simple function which is not having any direction. That's it. Simple function which is not having any direction. That means the temperature function in a room is given by x plus yz degree Celsius. What does that mean? Let's just say this is your room. This is your room. The coordinate system is your room only. Coordinate system is nothing but your room. So in your room at coordinate 1, 1, 1, what is the temperature? At this coordinate the temperature is 1, 1, 1. The temperature is 2 degrees Celsius. Here the temperature is 2 degrees Celsius. At 2, 1, x y equals to 2, or let's take any random point, although it cannot be possible. Let's take at 2, 2, 2. What is the temperature? At 2, 2, 2. The temperature here is 6 degrees Celsius. That means at different point you are having different temperature. No, at this point you will be having a different temperature. Here you will be having a different temperature. Here you will be having a different temperature. Here different temperature. Here different temperature. Here different temperature. Here different temperature. So at different point you will have different temperature. So it is a scalar field. No, it has nothing to do with the direction. Right? So every point is defined having only a magnitude. That means let's just say this is a point A. So at point A you are having 2 degrees Celsius temperature. Only the magnitude is there. It's not that I am having 2 degrees Celsius temperature in I cap direction. I am having 3 degrees Celsius temperature in J cap direction. Nothing. Here you are having 2 degrees Celsius temperature. Here you are having 6 degrees Celsius temperature. Here you might have 7 degrees Celsius. Here you might have minus 1 degree Celsius. Here you might have minus 3 degrees Celsius temperature. So this is the meaning of scalar field. that there is no direction, simple field like this, a simple function, that's it, simple function. Sometimes it is known as point function as well, scalar point function, point function. Why do they call it point function? Because it is defined at every particular point, no? At 2, 2, 2, the temperature is 6 degrees Celsius. At 1, 1, 1, the temperature is 2 degrees Celsius. That means at point A, temperature is 2 degrees Celsius. At point B, temperature is 6 degrees Celsius. So these are the points. For those particular points, the temperature has been defined. So that's why they might be known as scalar point function or scalar field. That means it is not having any direction. So this is how you can show the temperature. Okay, it is the image created by Gemini. So this is how it is showing the temperature. That let us say, let's take any random point. This is the point we are taking. Which point we are taking? This point we are taking. So here your x is -3, x is -3, and if x is -3, then you can say z is, this is your z coordinate, upper one is z coordinate, z is 2, and what is your y? Y is -3, y is -3. So what is the temperature you are getting? X equals to -3, y is -3, z is 2. So the temperature we are getting is -9 degrees Celsius. So at this particular point, the temperature is -9 degrees Celsius, and minus temperature they are showing with blue color. So they are showing it with blue color. Here you will get a positive temperature, roughly around 9 degrees Celsius temperature you will get. What is this point? Z equals to 2. What is the value of x here? What is the value of x? X is -3 again. X is -3, z equals to 2, and what is the value of y? Y is 3, and z is 2. So what is the temperature you will be getting? -3, 3 into 2. So temperature you are getting is 3 degrees Celsius. So here you are getting the temperature to be 3 degrees Celsius. At this particular point, the temperature is 3 degrees Celsius. So at different point in a room, there is different temperature. At different point, different temperature is there. So this is how the temperature is plotted. If the color is somewhat like this, then temperature is positive. If the color is somewhat like blue, then temperature is negative. Okay, so if you want the heated place, then you will stay here, and if you want the cooling place, then you will stay here. Right? So this is how it is plotted. I am just showing the plot, that this is how you will make the plot. So this is how it is plotted. You will never have to make the plot in the examination hall. I am just telling that this is the meaning of scalar field function. Okay, what is the meaning of scalar field? That it is not having any direction. Every point will be defined a magnitude. So it is a simple function. Just assume it is a simple function, nothing else. It is simply a function which is having only the magnitude. And if it is having a direction as well, then it is known as vector field function. Okay, vector field or vector point function you can call it. If magnitude and direction both we have. So vector field or vector point function. Two names are there, vector field or vector point function. So let's draw this vector field. A force in 2D space is applied as F equals to x j cap Newton. This is the force that has been applied. What does that mean? Only in 2D space we are drawing it. I will take the example of 3D space as well. So what does that mean? Let's just say this is your x-axis and this is your y-axis. So if you are at point 1, 0, x equals to 1, y equals to 0. If you are at point 1, 0, then force at 1, 0 is j cap. What does that mean? It is having a magnitude of 1 and direction of j cap. That means if you are at 1, 0, then someone is applying a force which is equals to 1 Newton in the direction j cap. If you are at point 2, 2, if you are at point 2, 2, then x equals to 2 here, 2 j cap. That means someone is applying a force of 2 Newton in the direction of j cap. Someone is applying a force of 2 Newton in the direction of j cap. If you are at -2, -2, if you are at -2, -2, although if this is 1, then this vector will be a bit larger, no? If this is showing 1 Newton force, then this is showing 2 Newton force. So here what you will be getting, -2 j cap. That means magnitude is 2 and direction is -j cap. So if you are at this particular point, then someone is applying a force of -2 Newton. Someone is applying a force of 2 Newton in the direction of -j cap. 2 Newton in the direction of -j cap. Similarly, if you are at point x equals to 3 and y equals to, sorry, x equals to -3, y equals to 1. Okay, x equals to -3, y equals to 1. So someone is applying a force of 3 Newton in the -j cap direction. Applying a force of 3 Newton in the -j cap direction. this much force someone is applying a force of 3 Newton in the minus j cap direction. So in that manner there will be infinite kind of vectors. No, infinite vectors would be present, infinite vectors would be present. In that manner there will be infinite vectors would be present. So this kind of vector field we will be getting, that there are vector field lines, right? Any random function you can make. Let's just say I made this function x plus y I cap plus y plus zx j cap plus 3z square plus xy k cap. Let's just say I need to find out what will be the value of my vector field at 1 comma 1 comma 1, at 1 comma 1 comma 1. So the value is coming out to be 2 I cap plus 2 j cap plus 4 k cap. So at 1 comma 1 comma 1 you need to make a vector of amplitude which will be under root 2 square plus 2 square plus 4 square, and this will be the direction. So you need to make this vector at 1 comma 1 comma 1. Where will be 1 comma 1 comma 1? Let's just say it is somewhere here, 1 comma 1 comma 1. You need to make this kind of vector. So at different points you are having different kind of vector, and this is how it will be shown. So did you understand the meaning of vector field lines? Again and again I will be using this term, vector field line, vector field line. What is the meaning of vector field lines? That means a lot of vectors are there. There is a function which is defined in terms of x and y. Here I defined only in terms of x. It could be defined in terms of x, y, z, and different vectors are possible. So did you understand the meaning of vector field? Vector function, vector field. This is a vector. 2 I cap plus 3 j cap, this is a vector, plus 5 k cap, this is a vector. But 2x plus y I cap plus 3 j cap plus 5z k cap, this is a vector field function. Is that understandable to you? Okay, so I hope you would have understood the meaning of vector field and scalar field. Scalar field means it is not having a direction. Vector field means it will have a direction. So it is simply a field which is having a direction. It is a field which is having a direction. So a lot of vector lines will be there. If I say my A vector is this much, that means what does that mean? That means in your 3D coordinate system, my vector field A is somewhat like this. That means in 3D coordinate system you will be having a lot of vectors. In 3D coordinate system you will be having a lot of vectors. In any direction, in which direction? In any direction you will be having a lot of vectors. So this is how I can make a random field A. This is a random field A I have made. And what do you mean by scalar function? Scalar function looks somewhat like this. That at different points you will have different magnitude. It will not have any direction. Different magnitudes would be there. And this is how you can show it. So in the next video we are going to start our vector calculus. Now you know everything, every single prerequisite that was required about the vector calculus. I know this video might be a bit strange, right? Because here you are learning a particular concept and then you are not using it. I learned it, but I did not use it. So whatever that you have studied now, everything will be used in future. So again and again revise this lecture. If you are referring to the new lectures, no, then again and again you will have to revise this lecture. Otherwise you will not be able to understand anything. So again and again keep on revising it, and surely you will be loving vector calculus for sure. And integral calculus you need to study, then only you will be able to understand vector calculus. Otherwise you will not be able to understand. So the basic prerequisite that I told you, that these prerequisites you need to cover. Otherwise don't think of studying vector calculus at all. Okay, yeah, thank you very much. Let's meet in the next lecture. We will start with that differential vector calculus. Okay, yeah, thank you very much. Happy learning.